the union of all the sets will cover all the elements, right? But what we want to do is we want to find the smallest number of sets that cover all elements at least once, right? So in this example, these three sets, if you remove them, the remaining 4 sets is the minimum number of sets that cover all elements at least once. Yeah, this is a classic combinatorial optimization problem. If you have taken, and it's an NP-hard problem as well. In fact, it cannot even be approximated to a better than log n approximation unless p equals NP. Right, so super hard problem, but still we would like to, we want to solve it because it's super important. It shows up in a lot of operations, kind of day-to-day operations applications, right? And it turns out that a simple greedy algorithm already achieves this log n factor approximation, which is the best possible. Right? So there is another equivalent characterization of the minimum set cover problem, which we will use for this talk. It's the graph formulation. So we are given as input a bipartite graph. The left side is the gray vertices, which denote the elements. The right side is the blue vertices, which denote the sets. Right? So we have n plus n, n elements and n sets. So we have n plus m, which is capital N vertices. And the edges denote set inclusion. So an element and the set have an edge between them if the element belongs to the set. Yeah, and so equivalent formulation of the set cover in this as a graph problem is to select the smallest number of blue vertices such that all the gray vertices have at least one selected. Right? So now we have come up with a graph formulation which is arguably easier to understand. Yeah, and it turns out that the set cover has been studied quite a lot in the distributed and parallel setting already. Yeah, many distributed and parallel models such as PRAM, local, congest, and so on. And typically people are interested in log n approximations. I say typically because yeah, there are other interesting approximation factors too, but we will stick to log n approximation for the purpose of this talk. Yeah, so it turns out that in the local model, you can solve this problem in log squared n rounds. Yeah, and this is a classic distributed model, which we won't talk about. And this algorithm somehow also implies a log squared n round algorithm in the MPC model. But first, what is this MPC model even stand for? It stands for massively parallel computing, not multi-party computation for the crypto. Yeah. So it's a theoretical abstraction of several massive graph processing models such as Apache Spark and Hadoop and MapReduce. Yeah. So the way it is defined is by a set of machines. So here I have a set of 4 machines. You can have an arbitrary number of machines. And the input is an n-vertex graph, n-node graph, which is distributed across all of these machines. So think of these as like off-the-shelf machines, and the graph is very massive, and we split the graph somehow and distribute them across these machines. Yeah, and since these machines are kind of regular machines, they have some memory restrictions. In particular, they have a local memory restriction of being strictly sublinear in the size of the input. Yeah, so you need to be, you have a really small amount of memory in all of these machines, right, compared to the size of the graph. Yeah, and this is a synchronous model, and in a synchronous round, each machine will receive at most W words from the same set of machines in the previous round. So these are the same set of machines in round t-1. They had sent some messages which will be received by the machines in this round, and they machines will then perform some local computation and send at most W words to other machines, which they will receive in round tables. Right? And note that apart from this, there are no restrictions. So basically each machine has a budget of W messages. It can send it to any machine it likes, right? As long as the all machines either send at most W words and receive at most W words. Right? So this is a very general kind of way of routing the messages, and the underlying communication network of these machines, it will easily support this. It is assumed that it will easily support this type of operation. Yes? So you can think of it in a very loose way as we are processing the input in n to the delta chunks at a time. Right? So, but it's a very weak way of looking at the model, but just for the sake of intuition. Right? So let's look at set cover in the MPC model. So you had this bipartite graph encoding of the problem. Right? So the same bipartite graph is just split across the different machines, right? And our goal is to design super fast algorithms in the MPC model compared to other distributed and parallel models. And this has been a recurring theme in this model, it turns out. And a prime example for this is the maximal independent set problem. So it turns out that in the local model, which is a standing example for a classic distributed model, this solving a computing a maximal independent set requires log n rounds. But it turns out that in MPC we can do MIS computation significantly faster, quadratically faster to be more precise. Right? So, but set cover has so far resisted such attempts of speeds. Whatever the round complexity is in local, the same was the state of the art in MPC. Right? And we asked the question, can we get a little O log squared in round MPC algorithm? Right? It turns out we can. Right? One of our main results in the paper is that we can get a log n approximate solution for set cover in log n to the 1.5 rounds. Right? So we shave off a square root of log n factor from the state of the art. This is standardized. Yeah. And sure, yeah, feel free to ask questions in the middle. I love being interrupted, so don't be shy at all. Yeah? Okay, so so I also wanted to mention some concurrent and independent work. So while we were, our paper in this conference was under review, this paper came out on arXiv, and it has since been published in this 2024, so it's already published. And they actually get the same results as us, and a little bit more. But I would like to point out that the results they get are not better than our results. So they are the same as our results. Yeah, so, and they use very similar techniques. So it turns out that we were not like the only ones who were thinking about these matters. But there has been a lot of wide interest in this problem as well. So let's look at the classic sequential greedy algorithm. I'll recap this algorithm now. So this algorithm achieves a log n plus constant approximation, which is the best possible. And the way it goes is it selects the set that covers the highest number of elements. Right? In this example, you just select a set that covers 2 elements, and you delete the covered elements, and you keep on repeating. So you select a set that covers the highest number of elements in the residual graph, and you keep on repeating. And this process, in the end, leads to a good approximation. Right? It turns out that this is a highly sequential algorithm. And as you might have seen, it's like every iteration is dependent on the previous iteration. And it is provably, it cannot be parallelized. So there is a counter example for this problem where it will take a linear number of iterations, right? But it turns out we can parallelize it, and it has these ideas for parallelization have been known since the 90s. We have algorithms from the 90s that are known to run in log squared rounds, parallel rounds. What they do is they have a threshold for high degree sets. Instead of taking the set that covers the most number of elements, you would relax this to some threshold. Right? And all the sets that meet this threshold of, let's say, a degree at least 2, of covering at least 2 elements, you randomly choose some of these sets using some mechanism. Right? That it could be a voting mechanism or just simple sampling or something like that. Right? And you end up selecting these 2, and you add these solutions to these 2 sets to your solution in parallel. Right? And basically you cover the elements and you delete them, and you keep on repeating this in parallel, and you repeat until no high degree sets remain. So there's one more set that you need to add, and you do that, and you then halve the threshold, whatever threshold you add, right? And you repeat again, and you keep on doing this until all the elements have been covered. Right? It turns out that this process also gives a comparable approximation guarantee if you are careful about the random choices and so on. Yeah. So a specific greedy algorithm which was came out in SODA 2020 is something that we use as a base algorithm for our MPC algorithm. It looks like this. So it has log n stages, log n iterations, and in each stage I and iteration k, you have some degree threshold for the set. If it's a high enough degree set, then you add it to the set cover with a certain probability. So a very simple algorithm, right? And it turns out that this gives a log n approximation also. Yeah, and one nice thing is that this inner for loop, where we look at each set in parallel and just add it with a certain probability, this can be implemented in constant MPC rounds. Right? So the entire algorithm can be implemented in log squared and MPC rounds. Yeah, and in particular, I want to emphasize this inner for loop, which is what you will take. So a naive simulation of this inner for loop runs in log n MPC rounds, but we will take a closer look at this and try to simulate it in faster than log n rounds. This is what we will do. Right, so another take on the naive simulation is that you look at a node in stage I, and you notice that in stage I, it can only depend on nodes that are within log n hops of this node. Right? You take a set, because there are only log n iterations. Anything farther from log n hops will never affect a node, affect the outcome at a particular node. So what you can do with this observation is that let's say a node knows its log n hop topology, right? It can compute the answer for the middle vertex without any communication. How? By just simulating the algorithm at all nodes. So the output at the middle node will be correct, but the output at the nodes closer to the edge will be wrong. But that doesn't matter. We have the correct output of the algorithm at node V. Okay. How does this help? So it turns out that we can use a standard trick in MPC called graph exponentiation, where the idea is that you basically, in every round, you double the radius that you know. How do you do this? You say that, assume that all nodes already know their R-hop topology, right? So this is a node that knows its R-hop topology. What it will do is, this node will ask all of its nodes within R-hops for their R-hop topology, right? So basically, it will gather the R-hop topologies of all its neighbors within R-hops. This allows this node to compute the 2 R-hop topology at V. just combines all of these sets that it receives, and you get a 2R hop topology, right? It turns out that you basically, since you double, if you want to get up to log n hops, you just need log n rounds, right? So if this were true, we would get a log n round MPC algorithm, but we got a log to the 1.5 n round MPC algorithm as a result. So there is a catch. So there is a memory problem. So what happens is that when you do even one step of graph exponentiation, you can violate the local memory boundary. So let's say you have a ball around a vertex, which R hop ball around a vertex which has n to the 1/3 size, right? And your local memory parameter is square root of n, right? So you are not violating the local memory parameter, but you do one step and you immediately violate, because you take n to the 1/3 nodes. All of them will have n to the 1/3 neighbors, right, in their R hops. So you will square your size, right, and it will immediately violate the local memory boundary, right? So, but the main observation here is you don't really need to collect the entire log n hop topology to know the outcome. You only need like certain specific vertices in the topology. So how do you keep these balls small without compromising on the radius growth, right? So the trick is that you use sparsification by sampling, right? So you sparsify these balls as you go along, right? So just a recap for the 3D algorithm. So there are two steps here. So one step here is you look at sets with high degree, n over 2 to the I in stage I, and in iteration k you add these sets to the set cover with probability 2 to the k over n. And so these two steps are pretty important for our sparsification. So let's take two steps here. So first we'll sparsify the sets, then we'll sparsify the elements, right? So in stage I, only the sets that have degree at least n over 2 to the I can be added to the set cover. These are the candidate vertices. Otherwise, that if condition is not satisfied, and you will never add this set cover, right? So either S is added to the set cover in stage I, or its degree falls below n over 2 to the I, right? Because in the last iteration of the stage, the probability actually becomes 1. So you add all the sets that kind of have at least n over 2 to the I uncovered elements, right? So here is a set with a lot of uncovered elements, right? So it turns out that for this set you need to estimate its degree in all of the iterations, right? So what it will do is it will keep a uniform sample of log n neighboring elements. Okay, it was disappearing behind the curtain, sorry. And this is used to estimate the degree in all of the iterations, right? And you can get this bound of degree of S, which is at least n over 2 to the I, because it is a candidate set, and it will be at most 2n over 2 to the I, because because it doesn't fall, right? So its degree has to be below. Its degree cannot be more than this, because in the previous iteration it would have been eliminated, right? So at most n over 2 to the I minus 1. So basically, because you need this condition where you need to keep only log n elements for each set, you sample each element with probability 2 to the I times log n over n. And this allows you to keep theta log n neighboring elements. And this is just checking the state of these elements, whether they are covered or not, is enough to get a good estimate of the degree in all iterations. Similarly, for sparsifying the elements, in iteration k, you take a candidate set which is added to the cover, and it's added to the cover with probability 2 to the k over n. Right? And if you add these probabilities through all the iterations 1 to k, you just get 2 times 2 to the k over n. Yeah, so for an element that is being that we're trying to sparsify, we show a lemma where we show that the uncovered elements have at most n log n over 2 to the k candidate neighbors, candidate sets that are neighbors with high probability. Why? Because each of the sets will be, if any one of the sets kind of selects itself to be added to the set cover, this element is already covered. So none of these n log n over 2 to the k sets have to select themselves. Right? And the selecting probability is 2 times 2 to the k over all iterations. Right? And this is at most 1 over n squared. Yeah? And so what we do is we kind of take these log n iterations and kind of split them into square root of log n batches. And in each batch, if we look at the size of the square root log n, if we look at the number of sets that can be that can be neighboring an element, it turns out that it's 2 to the b times log n, 2 to the square root, roughly 2 to the square root of log n. Right? So if we put it all together, we sample the sets, we sparsify the sets, by sampling of log n elements, and we sparsify the elements by sampling 2 to the square root log n neighboring sets. Right? So the radius of the ball is basically the number of iterations we want to simulate, which is square root of log n. So the size of the ball is the number of neighbors, the degree raised to the radius. So it's 2 to the square root of log n raised to square root of log n, and this is within our memory band. Right? So this square root of log n radius ball, therefore, it fits into our memory, and therefore we can do graph exponentiation to gather it in log n rounds and simulate square root of log n iterations in log n rounds. This gives us a square root of log n factors. Just to recap, we get a log n approximate set cover in log to the 1.5n rounds. And this is in the low memory regime where we have strictly sublinear memory. But if we put delta equals 1, basically, we have near linear memory per machine, then we can actually even remove the extra 0.5. So we get a log n factor improvement. So I urge you to look at the paper for this. This is a really simple trick here that we use. Right? So I will conclude with some open problems. So this log n to the 1.5 rounds in low memory MPC seems quite arbitrary, at least to me it does. Right? So my question is, can we get a little, can we get even better than this, like log n rounds in the MPC, or even little log n rounds in MPC for set cover? Right? Can we get good deterministic bounds for log n approximate set cover? The sequential algorithm is deterministic. Right? Why can't the parallel algorithms be deterministic? Or why do the parallel algorithms even need randomness? Right? And then there are other generalizations of set cover, like partial set cover, capacitated set cover, multi-set cover, which could be studied in this setting. With that, I thank you and stop the questions.
Thanks for a nice talk. Any questions?
Thanks for the nice talk. So a machine can send and receive W words, right? So how we are making sure that it will receive only W words, and if it is receiving more than W, then which words are getting?
Okay, so that's a good question. So if it, so that's basically a thing that an aspect that is left to the algorithm. So a good algorithm in the MPC model will always follow this criteria. Right? So that's the decision that is made in this. this model. You could study variants where you drop certain messages and so on, but typically when we design algorithms, we always make sure that you send and receive at most 20 words, or your local memory parameter is never violated.
Any more questions?
Well, very nice presentation. One question which is slightly outside what you have presented, or what you have worked on. Suppose that you have a solution with three machines. I give you one more machine. Once you come up with a solution, I give you one more machine. Can you make incremental adjustments?
Yeah, that's a nice question. So, so first of all, one thing is that you need enough machines to store the entire input, right? So if you have 3 machines, then your local memory has already kind of shot up quite a lot.
Yeah, but from 3 to 4, if I give you one additional machine, then
right.
you have more memory.
Right, so it's still constant terms, right? So in theory, like constant is constant, even if it's 1 or 10 million. Right? So that's like a theoretician's answer, but I agree that from a practical perspective, it does make a lot of difference. At least in this model, there is not such a fine-grained distinction yet. So it would be nice to add it, I would say.
Thank you.
So let me add what he's continuing. Let's say the same thing I had in mind. Let's say the number of messages may be less, but the memory is unlimited, but I restrict on the age constant. I mean, the age one, the message you can send, let's say, login or login. Okay. Do you think that this can be improved? Because then possibly that R of things might be done. Again, I mean, you cannot send because of this age constant.
Right. So this is kind of similar to the K machine.
Exactly.
So you let's say have a set of K machines. Then what happens is that you get somewhat weird running times in a sense. So it depends on both the input size and the number of machines. Yeah, so here it's kind of at least theoretically a little bit nicer in the sense that you don't really have to worry about too many parameters. But I think a lot of these techniques will work because at least if you have like a well-connected network amongst the machines, you can do all these exponentiation tricks. And the fact that you have limited bandwidth, it kind of does put a limit on your memory in a sense, because you cannot receive more amount of messages per round than your bandwidth. Right? So it does put some sort of artificial memory constraint, even though it's not exclusive.
Okay. Anyone, any quick questions, or maybe we already have enough? Okay, so let's thank again the speaker, and let's prepare for the next talk, the next distributed computing, from the distributed computing track. The next paper is Black Hole Search in Dynamic Graphs. This will be presenting by Tanvi Kaur, and it's a joint work with Kaushik Mandal, Ashish Saxena, and Parthasarathi Mandal.
I'm here to present today's talk on black hole search and dynamic graphs. This is a collaborative work with Ashish Saxena, Parthasarathi Mandal, and Dr. Kaushik Mandal. This is going to be the outline of our talk. We'll begin with the introduction, followed by the setup we'll be working on. Then I'll formally define the problem statement, and I'll highlight some of the existing literature. I'll give a high-level idea of the results we have given in this work, and finally conclude with some of the open problems and the references. So what is a mobile agent? Mobile agent is a software entity that is endowed with limited memory and it is capable of traversing the network. So employing mobile agents to solve various problems is very widely studied in the recent decade. Many problems such as exploration, gathering, dispersion are studied in this paradigm. But practically if you see, inconsistency and faults are unavoidable. So these faults can be in various forms. They can be in the form of faulty nodes, faulty agents, or dangerous graphs. So from the perspective of dangerous graphs, black hole is one such issue. What exactly is a black hole? It is a dangerous node that is present in the graph and it disposes of any resource that enters into that node without leaving any trace. So practically, it is a resident process which can be seen as a virus on a network site that deletes any incoming data. In a cloud, a node that causes loss of essential data can compromise the quality of any service in that cloud and become a black hole. So the objective is that it is very essential to locate such node in the graph. Otherwise, it can create a huge problem. So at least one agent should survive and terminate after determining the presence of this black hole in the graph. So in this work, we deal with this problem. It is well studied in the context of static graphs, that is the graphs whose topology does not change with time. For dynamic graphs, it is studied only for very specific topologies like dynamic rings, dynamic cactus, and dynamic tori. Now, it is interesting to look to search for a black hole in an arbitrary dynamic graph. So, in this work, we will be dealing with the arbitrary graphs. The model which we are working on is, we consider graph to be, G is the underlying static graph. It is also known as the footprint graph. The nodes are considered to be anonymous, that is, they don't have any identifier, and each node is equipped with a whiteboard that has storage order of log delta V. Here delta V is the degree of a node V. The graph is considered to be port labeled, that is, each edge associated with the node is uniquely labeled from the range 0 to the degree of that node -1. And the system is represented as a time varying graph, which is represented with this tuple V, E, T, and rho. V and E are the set of nodes and the set of edges. T is the temporal domain, which is considered to be positive integers, as in this model we are considering these 3 time steps. And rho defines whether an edge is present at a particular time or not. Now the adversary has the power to delete edges from the footprint graph at each time step, provided the graph remains connected in that round. So, for the agents, we consider K agents that are arbitrarily positioned at safe nodes. Safe nodes means all the nodes except that black hole. Each agent has a unique identifier in the range 1 to n raised to the power c, where c is some constant, and each agent is aware of its ID. Agents do not have any prior knowledge of any of the global parameters, such as n, delta Vh, where delta Vh is the degree of black hole, and delta, that is the maximum degree of the graph. And the agents are equipped with order of log n memory. An agent residing at a node knows the degree of that node in the footprint. However, it does not understand if any incident edge is missing or not. So basically, if it is present at a node say V, it is able to see the degree of that node. But it does not know whether the edge associated with the port label is present or not. So when it tries to move through that port in that round, only then it will be able to understand whether that edge was present or not. So basically, it can have successful move if the edge is present or unsuccessful move if that edge is not present in that round. So in our model, we consider this that agent can understand whether the edge is missing only by traversing through it. So the same thing which I said, that it can be understood by the agent in the starting of the next round. However, in the existing literature, as I said in dynamic cactus, tori, and rings, the authors consider that edge associated with it is present or not can be understood by the agent in the same round itself. So thus in this scenario, the agent can never have any unsuccessful move. For the communication model, in each round, agent performs In the look phase, the agent reads the contents of the whiteboard. It can see whether the other agents are present and the parameters of those agents as well. And the agents also understand if it had a successful or unsuccessful move in the previous round. In the compute phase, based on the information gathered from look phase, the agent decides the code it has to move through and whether it has to move or not, definitely. And in the move, the computed code, it attempts to move in that round. So if the corresponding edge is present, then the agent will be moved through it, otherwise it will remain at the same node itself. So formally our problem is FBHS. We consider the graph to be a time varying graph and it has a black hole present in it. K agents are arbitrarily positioned at the safe nodes and the agents have no prior information about the black hole or location of the black hole or the missing edges, and nor does the agents know any of the global parameters. And the adversary can remove at most F edges from the graph provided the graph remains connected. So the objective is that at least one agent should find the black hole in the graph and terminate. So if F is equal to 1, the problem is 1 BHS, means the adversary can delete at most one edge at each round. So in this work, we consider both 1 BHS and F BHS. This is the summary of existing results. For the case of rings, here R represents the rooted initial configuration and A represents arbitrary initial configuration. For rings, the authors provide a complete characterization of the problem of 1 BHS in different models such as face-to-face communication model, whiteboard model and Pebble, and they also provide a lower bound on the number of agents present, number of agents required to solve 1 BHS, that is 3. And for dynamic cactus, the authors consider only rooted configuration and they solve 1 BHS and F BHS. The communication model they consider is whiteboard communication, whiteboard is present at each node and face-to-face communication model, and the minimum agents required are such. For Tori, the authors consider only 1 BHS and they consider similar kind of model and provide a minimum number of agents required for different cases. So we provide lower bound result on the number of agents and also algorithm for 1 BHS and F BHS from the rooted initial configuration. However, in this case, the agents do not know do not understand whether an edge is missing or not, and the model considered the same whiteboard and face-to-face communication model. So I'll begin with the impossibility results. Our first result is impossibility for 1 BHS. We say that it is impossible for 2 delta BH many agents to solve 1 BHS with agents having order of log n memory and the nodes having order of log delta V storage. So this is the construction. Let us suppose the central node is the black hole and these CLs are the cliques. CL1 is first clique, CL2 is second clique and CLBH is the delta BH many clique. And the size of each clique, it consists of root and many nodes. And each clique consists of 2 agents. Now, this we understand that the adversary cannot delete any of these cut edges, EIs, because that will make the graph disconnected. So, if in order to find the black hole, the agents have to move through EI, otherwise they will never be able to determine the presence of black hole. So, if the first agent moves, it dies. But the second agent present in that particular clique cannot understand whether the agent died due to black hole or the agent is not able to return or so because of there was a missing agent. So the possibilities are, if both the agents wait forever in the clique, then they will not be able to determine the black hole. The second case is that if one agent dies and the second agent waits forever in the clique, in that scenario also black hole is not determined. And the third case is both the agents die in the black hole. So in this scenario also we don't have our objective solved. So we see that 2 delta BH many agents cannot solve 1 BHS when they are in the scattered configuration. The second result is for F BHS. Now the adversary can delete at most F edges from the graph. So we say that 2F plus 1 many agents cannot solve FBHS even from the rooted initial configuration, even if they have infinite memory and the graph has infinite storage. In this scenario also the 2f plus 1 many agents cannot solve FBHS. The construction is like this. We consider a clique of size f plus 2 now. So let us suppose that BBH is the black hole and the remaining nodes are safe nodes. Each safe node Vi is connected with a black hole via EI, and any two safe nodes Vi and Vj is connected via the edge Eij, suppose. So let us suppose all the 2f plus 1 many agents are positioned at one of the safe nodes, say V1. Now, if none of the agent moves through this EI edge, they will not be able to determine the black hole. So at least one agent has to move through the edge EI. The thing is that, let us suppose that A is the algorithm that successfully finds the position of the black hole using 2f plus 1 agents. So we provide the adversarial action in each of the situation. If there is some information corresponding to some other agent that it has moved through edge EI, and there is an agent present at a safe node Vi, and let us suppose that adversary knows that this agent, blue agent, is going to move through EI in this round. So at the beginning of that round, the adversary is going to delete that edge. That red edge denotes that the edge is deleted by the adversary in the starting of that round T. The second rule is that if the blue agent is present at a safe node and it is going to move through edge EI, but there was no information present at the node Vi, in that scenario adversary does not need to do anything. The third rule is that if at least two agents are present at the node Vi and they are going to move through edge EI that is connecting to the black hole, in that case also adversary is going to delete that edge EI. Next rule is that if agents are going to move from a safe node to a safe node, in that case adversary does not need to do anything in that case. And finally, if agents are present in the graph, since the adversary can delete at most f many edges, so the movement of all these f agents can be permanently blocked by the adversary. So what happens in this case is, if the agent does not move through the edge EI at all, then it is never possible to determine the black hole. Because the agent can move from a safe node to a black hole only if there was no information present corresponding to some other agent, and only if the rule 2 was followed. The second rule was followed, that is, there was no information at the node and the agent wanted to move through the edge EI, only then the adversary allows the agent to move through that edge. So with this, by following these rules, at least f plus 1 many agents can die at the black hole, and at most f many agents have the information about the codes that are used by the agents. So f agents are left at safe nodes and their movement can be permanently blocked by the adversary using the last rule. So this shows that 2f plus 1 many agents can never solve FBHS. Now I'll provide a high-level idea of an algorithm to solve 1BHS from rooted initial configuration. We use 9 agents from rooted configuration to solve 1BHS. Our approach is simple. We first provide an exploration strategy that uses a group of 3 agents. Using this strategy, we say that each node is visited by at least 1 agent. The next thing is we provide a strategy for cautious swap by a group of agents. This ensures that all the agents does not die into the black hole, at least 1 agent survives. So by combining both of these, we say that if each edge movement conducted by the exploration is replaced with a cautious swap, then we can solve the problem of 1BHS. So first I'll highlight the exploration strategy using 3 agents. Let us suppose that 3 agents are there, A1, A2 and A3, and their IDs are in this order. A1 is less than A2 is less than A3. All the agents begin to execute the depth first search traversal unless they encounter a missing edge. Now if they encounter a missing edge and none of the agents move, then they are blocked at a point. So what we do is, the smallest ID agent, it waits there for the missing edge to reappear. But the remaining agents, they deviate from the depth first search traversal. So what do? Either they skip the edge or they restart a new DFS traversal. So this is the formal description is included in the algorithm. I'm just giving the high level idea. So based on different cases, either they are going to skip the edge or they restart a new DFS traversal. So with this, what do we ensure? We say that the smallest ID agent, it is never going to deviate from its original path. And missing edge can block at most 2 agents, one from each side. So that at least in each round, at least one agent definitely is going to move. So we say that at least one agent explores the graph in order of E square rounds, where E are the number of edges in the graph. If none of the agents are blocked, then in the 4E rounds, the graph is explored. So let us suppose that first agent A1 or the group of agents is blocked before 4E rounds. So A1, if within the first 4E rounds there is no missing edge, then A1 is going to explore the whole graph. Suppose A1 is interrupted before 4E, then within the next 80 rounds, A2 is either going to be blocked at the other end. Let us suppose it is going to be blocked at the other end. In that case, the third agent, that is A3, now it is never going to deviate. So within the next 16E rounds, it is going to explore the whole G minus the missing edge. If this edge UB is deleted from the graph for these many rounds, then the third agent explores the whole graph minus this missing edge. So definitely if it is not, if A3 is blocked at some round, then A1 or A2, it moves. So we claim that at each round, at least one agent is definitely going to make one movement. So this shows that each node is explored by at least one agent, and a group of 3 agents is going to explore a time-varying graph, provided it does not contain any black hole. However, since our graph contains a black hole, each movement has to be done cautiously. So the task performed by a single agent in the exploration strategy is replaced by cautious movement by 3 agents. So the 3 agents, we consider one leader and 2 helpers. These helpers have to ensure the safety of this leader. So basically, before making a movement, these helpers first check whether the movement they have to move is leading to a safe node or not. Only then the leader is going to move into that node. So this is a flowchart that represents the cautious walk. Let us suppose A1 is the leader and A1 dash and A1 double dash are the helpers. So firstly, what A1 dash does, it moves. Let us suppose that these 3 agents have computed port P1 to P to move through. So the first helper A1 dash, it moves through port P. If the movement is unsuccessful, it reattempts. But if the movement is successful, in that case, A1 dash, in the next round, A1 dash has to return to the previous round and A1 double dash has to move through port P to see whether the edge was missing or not. Now, if this movement is unsuccessful, they reattempt this. Otherwise, if the movement is successful, then the leader checks whether A1 dash returned or not. If A1 dash returned, then this means that the node was safe and now they can safely move to the adjacent node. But if A1 dash does not return and A1 double dash has moved to that node, this means there was a black hole and A1 now knows the location of the black hole. So using this strategy, we see that one BHS can be solved. One BHS can be solved using 9 agents. So the final is similar to that of algorithm that we use to solve one BHS, that is exploration and replacing each movement of the exploration using cautious walk. We use this theorem, that is a graph in which adversary can delete at most f edges from G. 2f many agents can explore such a time-varying graph within this many rounds, where delta is the maximum degree and each node has order of log delta with storage. So finally, we have our theorem that the problem of FBHS can be solved using 6f agents within 3 delta raised to the power n, delta plus 1, 2f plus n times n minus 1 raised to the power 2f rounds, and delta is the maximum degree of graph. So we can observe that if we replace f with 1, then we can solve one BHS using 6 agents, though there we required 9 agents. But here the time complexity is very huge. So, but there we were able to solve in order of E-square rounds. So I'll conclude with the future work. So we have proposed algorithm for 1 BHS and F BHS from rooted initial configuration. Solving this problem from arbitrary initial configurations is still open. And here we are saying that the problem is at least one agent should survive and at least one edge leading to the black hole. However, this is also interesting to look into that we want to know all the edges that are leading to the black hole. So these are the references for my slides. Thank you.
Any questions? So we have time for a couple of questions if you have. So let me ask you one question. So let's say, are you assuming that initially when the agents are starting, they are in a group?
Yeah.
So at least 2 agents are there. Otherwise, let's say in some node there is only a single agent. So how it will work?
At a node there is only?
There is a single agent at a node.
No, but we are considering a group of 9 agents.
So each group must have some multiple.
No, for FBHS you are asking for 1 BHS.
Whatever, and both.
For 1 BHS we are considering initially there is a group of 9 agents.
Oh, that has to be in a group.
Yeah,
not
that is from rooted initial configuration.
Okay, and for the FBHS?
FBHS also we have solved for rooted initial configuration. We are considering 6F many agents. So that is also initially they are rooted.
So in case, let's say, initially the agents are distributed arbitrarily, so probably this will not work.
No, this will.
I see. Fine.
So how have you fixed that number 9?
Because we are able to explore the graph using 3 agents. So, but we are replacing each exploration using cautious walk. So for cautious walk, we need 3 agents. So the work which was done for exploration using 3 agents, now each work is to be done, means for 1 agent we require 3 agents. So exploration was done using 3 agents. So if we want to add cautious walk also, so 9 agents are required.
Any questions? Comments? Okay, so nice presentation. Let's thank the speaker again. So we have now another 2 papers from the networking track. So the paper now is renting servers for multi-parameter jobs in the cloud. We presented by Lata and Narayana. It is a joint work with Yakio, Mehtab and Dennis. Over to you, Lata.
Is microphone working? Yes. Thank you for the introduction. So yeah, this is about renting servers for multi-parameter jobs in the cloud. Is this right? These are my co-authors. So there's Yacha V, who was our postdoc at Concordia, Mehtab Masuri, who's our PhD student, and there's me and Dennis Pankratov, who are at Concordia. Okay, so the problem that we are looking at is motivated by the problem of request dispatching in cloud computing systems. So a cloud service provider like Microsoft Azure, for example, receives a sequence of jobs. Okay? These jobs have demands in multiple resource dimensions. So they may have resource demands for cores, for memory, for solid-state drive, hard drive, and network bandwidth. So these are literally the kinds of demands that you can specify for Microsoft Azure, for example. Okay, so what the cloud service provider has to do is to schedule these jobs on its servers, and the claim is that this scheduling is extremely important, and even a 1% improvement in the amount of fragmentation that you can achieve can save hundreds of millions of dollars per year. Okay, so this is a very practical and useful problem. So formally, what we have is we are given a sequence of jobs, all right, so sigma 1 to sigma n, and each job is specified by a triple, AI, FI, SI. Here AI is the arrival time of job I, or job sigma I, FI is its finish time, and SI is a d-dimensional vector. And in the jth dimension, SI denotes the size of the job in that dimension. So for example, it might denote the CPU requirement of that job. Okay, and another dimension is the memory requirement of the job. So the objective that we have is to assign jobs to servers of unit capacity in each dimension. And the objective is to minimize the total cost of all used servers. Okay, so let me give an example so that we are sure that we understand the problem. So let's say the first job comes in. So that triple says that the first job comes in at time 0. It's going to finish at time 6. And it has the demand vector is 0.5, 0.2. So in the first dimension, it has demand 0.5. And the second dimension shown on the right, it has demand 0.2. All right? So we place it in a server. We call it server 1. Right. Now the next job comes in, sigma 2. It comes in at time 1. It will finish at time 4. And its demand vector is 0.2, 0.9. So if you look at the second job, in the first dimension, it fits. It could be placed in server 1. However, it doesn't fit in the second dimension. The second dimension is already occupied, up to 0.2, so you can't have 0.9 of the memory, okay, on server 1. So we cannot place it on server 1, and we need to open a new server. So we open server 2 and place the second job in server 2. I'll just do one more job here. So suppose sigma 3 comes in now. At time 3, it's going to go till time 9, and it needs 0.2 and 0.3. We will see that it does fit in server, I think it does fit in the server 1, so we're going to place it in server 1. Okay? You can see that we could have opened a new server for this third job as well, but it would have incurred more cost. So the cost of this solution now is, how long is server 1 open for? It's open between 0 and 9, so it's 9, and server 2 is open between time 1 and 4, so 3. So the total cost for this particular input sequence is 12. All right? So this is the cost that we are trying to minimize. All right. So let's talk about some related problems. So first I want to mention that one-dimensional, I call it RSIC, renting servers in the cloud. So one-dimensional RSIC was introduced by Lee et al. In 2015, so it's been studied for about 10 years now. And in some papers, it's also called the min usage time problem. So clearly this is a generalization of the bin packing problem, the classical bin packing problem. It introduces a temporal component to the bin packing problem. Equivalently, we can say that it's RSIC, the bin packing problem can be seen as RSIC, where all jobs have the same start and finish times. Right? Other problems that have been studied that are related are dynamic bin packing. In the dynamic bin packing problem, also you have a temporal component, so jobs have arrival times and finish times and sizes, but the objective function is different. There we are trying to minimize the number of servers used. Here we are trying to minimize the total cost of the servers, that is the duration that the servers are open, the total over all servers. Also, I want to say that vector bin packing has also been studied, all right, which is also related because it's also a d-dimensional input. Okay, Alan talked on the first day about online algorithms, so it should be clear that RSIC is an online problem. Jobs are coming in one by one, and an algorithm has to process jobs one at a time as the job comes in, and it has to assign them to servers without any knowledge of the jobs that are going to come in the future, all right? And the usual way to analyze online algorithms is using its competitive ratio. So an online algorithm is said to be row competitive if there's some constant b such that for any input, the cost of the algorithm on the input sequence sigma is less than or equal to rho times the cost of an optimal offline algorithm, okay, on the input sigma, plus some factor b. Okay, so since bin packing is an NP-hard problem, we don't really know the optimal cost, all right, of since bin packing is NP-hard, so is RSIC, and since it's an NP-hard problem, we don't it's not easy to figure out the optimal cost for a particular sequence, for an input sequence. So what we will be using instead is lower bounds on the optimal cost. So let's look at some lower bounds on the optimal solution. So I'm going to show 3 different lower bounds, and we will use them all. So one lower bound is the so-called span of the input. So you take the length of the union of the intervals ai to fi. Okay, so for example, in this input, you can see that the span is, so the first job starts at the leftmost vertical line, and it ends there at the last vertical line, so this is the span. So clearly, any algorithm has to use at least this much, has to pay at least this much cost. Okay, the length of the interval from the left vertical line to the rightmost vertical line. If I just want to mention, not in this example, but if there are times when there is no job to be processed, we would exclude those. So that's why it really is the union of those intervals ai to fi. All right. So any algorithm has to use this much, including the optimal algorithm. Another important bound in the one-dimensional case, it's easy to see, is the utilization. We can think of this as a volume bound. So you take the duration of every job and multiply it by size, right? And so the sum of all this is called the utilization bound. In the case of d-dimensional input, we, instead of just the size, we take the L infinity norm of the size vector, which is the maximum size in any dimension. Right? So that's the utilization, but because we are using this norm, the optimal cost is not really lower bounded by the utilization, but instead by the utilization divided by d. All right? So we have this lemma saying the optimal cost on input sigma is always greater than or equal to the utilization on sigma divided by d. All right, a third lower bound is as follows. We say that a job is active at a time t if that time t lies between its arrival and its finish times. And let's say S of sigma t is the sum of sizes of all jobs active at time t. So let S of sigma t be the sum of sizes of all jobs active at time t. Suppose opt of sigma t is the number of servers used by opt at time t, then opt of sigma t must be greater than or equal to the ceiling of S of sigma t, again the L infinity norm. Okay, it has to, if you forget about the L infinity norm and you just look at opt, you're going to say the optimal cost is greater than or equal to the total size of jobs that are active at that time, the ceiling of that. Right? So you have to have at least that many servers at time t. Okay, so now what is the total optimal cost? You can integrate over t from 0 to the lifetime, all right, capital T. You integrate opt of sigma t, and it then follows that opt of sigma is greater than or equal to the integral 0 to t, S of sigma t infinity norm, the ceiling of that, as written over there. Okay, so these 3 are lower bounds on opt. Okay. So we've looked at lower bounds on opt or on any algorithm. What about upper bounds? So any algorithm for bin packing could also be used for RSIC. In particular, the any fit class of algorithms for bin packing basically says if you can use, if there is a server active in which you can fit the new item, you should always use it. So don't open a new server unless you have to. So if there's some server available that fits the new item, just add it to that server. Just assign it to that server. So many algorithms that you're all probably familiar with, such as first fit, best fit, worst fit, etc., are algorithms in the any fit class of algorithms. So in first fit, basically you open servers and you order them by order of opening times, and you always check servers in that order. All right? And in best fit, you try and add the job or the item to the server that has the least amount of available space but can still fit the new job. All right? So those are classic bin packing algorithms, but a couple of new algorithms have been proposed specifically for RSIC. There are more, but I've put the best known for the hybrid algorithm as the best competitive ratio. I've left out some of the algorithms that came in the intent. But I want to mention move to front, Move to front is an algorithm that's known from other contexts, I think list access, but here it was proposed for this problem, for the RSIC problem. And the idea is just this. So when you add a job to a server, you just move it to the front of the ordering, all right? And what was shown by experiments by Kamali et al. Is that it performs better than any of the other AnyFit algorithms. It's also an AnyFit algorithm, so it will use an existing server so long as one is available that fits the new job. Okay, another algorithm is the hybrid algorithm by Azar et al. And this algorithm basically classifies or categorizes servers by both duration of jobs and by arrival times, and then puts new jobs into the right category server. So, for example, jobs that have high duration will be assigned to a completely different category of servers, and jobs that arrive in a certain interval will be in a different category of servers. All right, so that's the hybrid algorithm. There's a subtle point here which might have been missed in my description of the algorithms, but basically algorithms can be either clairvoyant or non-clairvoyant. In the non-clairvoyant setting, or for non-clairvoyant algorithms, the algorithm does not know the finish time of jobs. It only knows the start time, or only uses the start time of jobs and the sizes of jobs. It does not know or does not use the finish time of jobs. In clairvoyant algorithms, the algorithm has access to the finish time of jobs and can use that. So hybrid algorithm, you can see, is actually a clairvoyant algorithm because it uses the duration of the job to decide which category of servers to put the job in. Okay, so hybrid algorithm is a clairvoyant algorithm. All the other algorithms that we looked at are actually not clairvoyant algorithms, they're non-clairvoyant algorithms. Okay, and so what's known about these algorithms and their competitive ratios? So RSIC has mostly been studied in the one-dimensional setting so far. And the lower bound for any non-clairvoyant algorithm is this parameter mu, which is the ratio of the longest duration of a job to the shortest duration of a job. All right? So this is known to be a lower bound on any non-clairvoyant algorithm. It was shown to be a lower bound on any non-clairvoyant algorithm. And algorithms such as first fit, next fit, move to front have all been shown to have competitive ratio order mu. This is not just some large constant times mu. The constant is, for example, for move to front is 2 mu plus 2, and for first fit is mu plus 3, etc. All right. The clairvoyant hybrid algorithm was shown to have competitive ratio order root log mu. So you can see that clairvoyant algorithms can clearly do better because there's a lower bound of mu on the competitive ratio of non-clairvoyant algorithms. Okay, the d-dimensional setting. So all those were results for the one-dimensional setting. The d-dimensional setting was studied for the first time in Moorreker et al. In a SPA 2023 paper. And they studied non-clairvoyant algorithms for RSIC. And essentially showed a lower bound of mu plus 1 times d. So they said if it's d-dimensional, the competitive ratio goes up by a factor of d, must go up by a factor of d for any fit algorithms. And they analyzed first fit, next fit, best fit, and move to front and proved bounds on their competitive ratios. All right? Essentially, generally, they go up by d, but not exactly by a factor of d. So what do we do in this paper? All right. So I would say there are two main theoretical results. So we show that upper bounds for the RSIC problem obey a direct sum property with respect to dimension d. In particular, we show how to transform any one-dimensional algorithm for RSIC to the d-dimensional setting, and the competitive ratio will scale by a factor of d. As a corollary, we obtain that the hybrid algorithm, when transformed in this fashion, gives you a competitive ratio of d root log mu. Okay? Another thing we do is we propose a new clairvoyant algorithm called greedy, and we show that it has competitive ratio 3 mu d plus 1. In fact, we do something more general. We see the property of greedy that enables us to do this analysis, and this analysis technique then applies to a subfamily of AnyFit algorithms that we call monotone AnyFit. I'll describe the property. And we also did extensive experiments on synthetic data, and our experiments show that greedy does really well. Okay? It has the best performance of all known algorithms. so far. Okay, so I'm going to talk about those two main results. So the first result is this direct sum property of RSEC. So let's take any arbitrary algorithm, ALG, for one-dimensional RSEC, all right? So what we're going to do is we will transform this to a D-dimensional algorithm. And it's pretty simple strategy. We're going to decompose the input sequence. What we're going to do is, for every incoming job, we simply identify the dimension in which its size is the largest. So the size is a vector, it's a D-dimensional vector. We identify the dimension in which the size is the largest, and we kind of shunt it to a separate job sequence that is that corresponds to the jth dimension, right? And note that this partitioning can be done in an online fashion. So as you receive a job, so we are partitioning the input into sequences in which each sequence, the ith sequence, the ith dimension of the job was the largest among all the sizes in other dimensions. Okay, but this partitioning can be done in an online fashion. And then to process that job, to assign it, essentially we just apply the one-dimensional algorithm ALG to this particular job, and we ignore the other sizes, the sizes in other dimensions, and we also categorize servers by these dimensions. So for jobs that are for the sequence sigma superscript j, you have a separate set of servers. Okay, so you just put them in that set of servers. Jobs are assigned to servers handling only jobs from sigma j. All right, so we are able to show that basically this works correctly. Capacity constraints will be satisfied in every dimension, and that the competitive ratio goes up by a factor of d. All right. So the rho of ALG d basically is d times the competitive ratio of the one-dimensional algorithm ALG. And this guarantee of the competitive ratio holds both for strict competitive ratio and asymptotic competitive ratio. And it can be applied to clairvoyant as well as non-clairvoyant algorithms for one-dimensional RSIG. So it does give you the same results as the Moreker paper, but they get slightly better results by doing a more careful analysis. So asymptotically, it will be the same, that there will be a small constant factor that they are able to shave off by looking at the algorithms separately. Also, as a corollary, for the clairvoyant setting, we can show that the hybrid algorithm has a competitive ratio of d square root of log mu. So that was the first result. Now let me go to the second result about the greedy algorithm and the class of monotone anyfit algorithms. Okay, so the greedy algorithm is as follows. We order servers in decreasing order. So this is also an anyfit algorithm. And what we do is we order servers in decreasing order of their current finishing times. That is the maximum of the finishing times of jobs that are currently in the server. Right? And then we just do it like we would do anyfit. So you're examining servers in this order, and you assign the newly arrived job to the first server that has enough capacity to accept the job. And if no such server exists, you open a new server and assign the job to it. Okay. All right. So I hope I hope you see that it's a clairvoyant algorithm, because in order to know the finishing times of servers, you need to know the finishing times of jobs in it. All right. So if it's a non-clairvoyant algorithm, you would not be able to do this. So it's a clairvoyant algorithm. I also want to mention, why is it greedy? Why do we call it greedy? Because basically the cost of the algorithm, the objective function is the total cost of all servers, and what we are doing is to assign it to the server that would increase this cost the least. So you have a current cost you're already paying, you're just increasing the cost the least. So that's why it's a classic greedy algorithm. And what's surprising to us was that nobody looked at this before. All right. I just want to briefly describe the monotone anyfit property. And essentially, an anyfit algorithm, the known anyfit algorithms usually employ some ordering. Some of them have fixed ordering, some of them have ordering that can change, such as for best fit. But it assigns jobs to servers based on a predefined order of servers. And we say it's monotone if a server overtakes another server in the ordering only when a new job comes into that server. So server SI will overtake SJ only if a new job comes into SI. Then we say it's monotone anyfit. So any algorithm with a fixed ordering has the monotone property. It can be seen that greedy and move to front will also have the monotone property. But best fit does not have the monotone property. I think I'm running out of time, so I'll try to be very quick here. If you look at this example, you will see that basically initially SI was above SJ in the ordering. Nothing came into SJ, but because the item with size 0.6 left, now the SJ moves up above. So it moved up in the ordering not because something came into it, but because some item left. All right, leaving more space open in the server that was initially above in the ordering. All right, so best fit does not have the monotone property, so this is not a trivial property of anyfit algorithms. So our result is that basically any monotone anyfit algorithm has competitive ratio less than or equal to 3 mu d plus 1. As a corollary, greedy and last fit, which has not been looked at much, also have a competitive ratio 3 mu d plus 1. I don't have time to go into the proof here, but it's a somewhat different analysis technique than what has been used in the past. Just want to quickly mention my experimental results. We did experimental results on uniformly generated data. Basically, the sizes were chosen uniformly at random, the durations were chosen uniformly at random. Servers have capacity e to the d. And what else? Yes, we looked at dimensions 1, 2, 4, and 5, and we looked at three different arrival rates. Our experiments basically show that if you have a better worst case competitive ratio, it didn't mean that you actually performed better in practice in the average case. In particular, best fit actually does very well, although in the worst case, its competitive ratio is unbounded, it's infinity. Okay, but it actually does quite well in practice, especially for higher D. Among non-clairvoyant algorithms, the best algorithms are move to front and last fit, which we analyzed for the first time here as a monotone anyfit algorithm. And greedy has the best performance in almost all cases among all algorithms, clairvoyant and non-clairvoyant. Thing we noted is that the difference in performance appears to narrow as D increases. We don't quite have an explanation for that. And as D increases, the competitive ratio does increase, although in our experiment it's always less than 2. It's not going up by a factor of D. All right? So to conclude, we propose 2 new algorithms, greedy and the hybrid algorithms. Greedy algorithm has the best performance in practice, even though it has a 3 mu d plus 1 competitive ratio. Hybrid algorithm has the best theoretical worst case performance. So, and we actually have results that are more general than that. Greedy is actually, there's a more general class of algorithms, the monotone anyfit algorithms. And the hybrid algorithm, the d-dimensional version, is derived by a general technique that converts any one-dimensional RSIC algorithm to a d-dimensional case. And we note that greedy is the best performing algorithm in the average case among the algorithms we tested. So as future work, we don't really believe that 3 mu d plus 1 is a competitive ratio for greedy. We tried hard, but we could not prove anything better. We hope somebody can prove that its competitive ratio is mu d, that's what we conjecture. There's also a result about randomized algorithms in the paper that I haven't gotten into, but it's open whether there's a randomized algorithm for the one-dimensional case with competitive ratio which is constant, not a multiple of mu. We are also interested in whether the results from our experimental section carry over to real-life industrial instances. Thank you for your attention.
Thanks for a nice talk. Yeah, Edith has some questions. So, is there any microphone?
So nice talk. Thank you.
Is that your comments or?
There's a delay. With the microphone. I wonder. It seems like you could consider a system where preemption is not allowed. I wonder if preemption makes it a lot easier to get good results. And also another question is, I know one of the problems that people encounter in these kind of systems is that when jobs have self-declare their resource use, usually they're conservative and overestimate, and that leads to oversubscription. So if that's another issue, I wonder if you look at that.
Yeah, no, that's very interesting. So yeah, we definitely are not allowing preemption, right? So generally also in the online setting, I guess, right? Like you would make your decision and now you have to live with it. But one could consider some kind of limited preemption or preemption with a cost, right? If you preempt, then there's a certain cost. Sorry?
It's worried about people not being truthful.
Yeah.
But it is possible in many systems.
Yes, yes. Yes, and Alan is saying here that we have to also worry about people being truthful if they're going to declare their, when they're going to finish. Is that what you're saying?
People don't know how to estimate their resource usage, so they're being conservative, and because they know they might be kicked out if they underestimate. So they're sometimes trying to overestimate.
Right.
I know from people who worked in
Yes.
this is
Yes.
what happens. So.
Yes, interesting. So I want to say two things. One is I think there's a version of bin packing where you're allowed to go over by a bit, and I think that, so your capacity is one, but the last item you place can go over. So it's not that you just, you assume the capacity is 1 plus epsilon or 2 or something, but you say, okay, it's like the garbage bin, like you're supposed to put it in the garbage bin, but the last item could stick out of the garbage bin. So there is a version of bin packing like that has been studied, and we did want to study it for our sake as well, but we have not actually done it. The other thing I wanted to mention is that the data set that we got, we finally our student did do some experiments on real life instances, and the Microsoft Azure set that we got was actually people don't give the estimate of a duration. They actually ask for resources like CPU, memory, etc., but they don't estimate their duration. So that was nothing that important. Yes?
In the analysis that you did, it seems that there's a central entity has all the information, right?
What has all the information?
Is one single entity has the entire global
Yes, yes.
So how will this analysis and these algorithms work if it is to be distributed? Because if you assume the cloud server getting requests from different clients, and even the server is kind of collection of multiple machines, and nobody has a complete.
Yeah, that's an interesting point.
Or maybe they can get global information after some time, but not immediately. They
Yeah.
have local information, have to make decisions. So it's like a distributed schedule.
That's right, that's distributed scheduler, yeah. So generally this problem has not, so we assume there's a centralized scheduler. So there's a bunch of servers, and there's one scheduler that is making the decisions, but you're absolutely right. It could be that there are multiple schedulers, perhaps looking at different sets of machines that are occasionally overlapping or something.
So the question is just, can these results be generalized to that setting?
No,
not obviously.
I think not obviously, and I think, are they looking at different sets of servers, or are they actually scheduling on the same sets of servers? Then there would be some contention, right? Like you don't want them to schedule, you don't want to, so it could become a completely different ballgame.
Yeah, it's not so trivial.
Yeah.
Okay, thanks.
Okay, I think, we are running out of time. Maybe we take it's an interesting talk and we take offline if you have some questions or comments. So we have the last talk in this session. Of course, after that we have to bring your energy for this last talk. This is the second networking paper in this best paper candidate session. The paper is stable matching based EV charging assignment in subscription based models. We'll be presenting by Professor Sajal Kumar Das. This is a joint work with Arindam Anurag from Mysore University of Science and Technology.
Full slide mode. It was there. Anyway, good afternoon, everyone. The talk I'm going to give is very emerging. Electrical vehicles are coming in the market in a big way. It was there. Nice. Okay, good. Sorry about it. So the talk is on a very emerging topic, electrical vehicles, and we're talking about the electrical vehicle chargings. Not much work has been there yet, and we are the first few probably to dig into the algorithmic aspects of this particular problem, how to best charge electrical vehicles, keeping the EV owners' perspective, as well as the vendors, the service providers' perspective. Okay? So we'll talk about the algorithmic framework using stable matching theoretic algorithms. But there's a lot of scope to actually work on. And given the topic is very emerging and new, I wanted to deliberately give a good breadth and depth of the talk, rather than going into much of the formalisms which is there in the paper. So I'll try to convey the message and the insights and the intuitions so that you get the points over there. So this is the outline of the talk. I'll give a motivation that why electrical vehicle charging is so important, and given that the growth rate of electrical vehicles are much, much more than the installation of the charging stations. So that's the first critical point. Then what are the novel contributions that we are making? We're talking about a subscription-based EV charging model, which is the first of its kind that we are proposing. And then, of course, talking about electrical vehicle to charging points within a charging station as a stable matching assignment problem, then do some performance evaluation with actual experiments. So why electrical vehicles? As we all understand, the electrical vehicles has a reduced dependency on the fossil fuels, if not zero. Also, it talks about the sustainability in terms of zero carbon emission, and as well as the reduces the fuel cost. If you give the number, electrical vehicle, actually the charging cost is 5 cents per mile as opposed to 13 cents per mile for the gas-based cars. Right? So that's one part of it. In many countries, you can see UK, Canada, even China, as well as the US, they're trying to decommission over the year the regular internal combustion-based cars. Right? So eventually everything will be EVs. But the thing is that in California, for example, they're expecting by 2030 about 5 million electrical vehicles on the road. Okay? And you see, this is the growth rate. Growth is extremely massive. It's more than 60% per year, the growth. And if I give you the projections, which has been actually mandated, that by 2030, the total number of EVs that will be in the market worldwide is about 250 million. And about 30 million will be in the US. But the growth rate is about more than 60%, whereas the charging stations is growing about 22%. You can see these discrepancies. The question is that if you're on the road with the electrical vehicle and you don't get the charging stations, what do you do? So these are the very challenging questions that we'll be addressing over here. So, but there are some mandates are also coming. Mandates are like this. For the sustainability, the EV to charging station ratio should be 10:1. And that is coming from the Department of Energy in the US. And then in the US, it's many states, it's actually 25:1. So 25:1. And the research challenges that what are the research questions that we can ask? Since you have limited number of charging stations availability and unpredictable charging requirements, because you never know how you'll be driving and all this in the roads, your routes and everything, that basically means you have much longer waiting time given that fewer charging stations. Right? And that also causes user dissatisfaction. So that is one from the user's point of view, right? The other anxiety that is there, for example, you have to drive for another 50 miles. The question is, if I don't get a charging station, or if I have to wait for a longer time, can I reach my destination? And that causes anxiety for the users, right? On top of that, the users also have different diverse preferences because they want to minimize the number of detours. For example, I was there for 1 hour, did not get the charging, I had to go to another place. What is the best way to detour that? Then fast charging and also competitive pricing. So you're basically talking eventually, actually you are also looking into from the game theoretic perspective, the user side as well as the service provider side, right? So this particular problem of finding appropriate charging points within a charging station for electrical vehicle is a very complex problem because there is a lot of stochastic nature of the waiting time as well as the charging requirement and the preferences. So that's the motivation part of the problem. Just to give a little bit actual model, so we'll be looking into the last one. So different types of electrical vehicles are there. The hybrid models are there, gas and battery, as well as the plug-in hybrid model, and all electrical vehicles model, right? So the right one that we are talking about, that all the car companies are the Hyundai, Tesla, Toyota, Nissan, everybody has their own models. But the reality is that this charging rate is also not very high. So there are different levels of charging. The specification is there for the Department of Energy, called level 1 charging, level 2 charging, level 3 charging. Something is called regular charging, something fast charging, depending on the number of hours or minutes that you take for charging. So in terms of the voltage charging as well as that. And the level 1 is mostly that you have in the garage, probably in the residential area, or the sort of more commercial enterprises that are providing service. So you have the service providers or the vendors providing EV charging, and of course the users are there, so you have to look into the thing. Now some methods are actually being proposed recently in the last few years, and if you just take a look at the chart, so basically we are talking about algorithms, and we'll actually show that this assignment of EV to the charging points is actually an NP-hard problem, and that can be actually proved very easily. But lots of approximation algorithms are there. Sometimes they take into account the stochastic nature of the Lagrange function. Sometimes you have different approximation algorithms, some genetic algorithms, as well as we are actually proposing a matching theoretic algorithm, which is also an approximation algorithm, because otherwise it should be very hard. So the goal is to develop efficient assignment mechanisms that consider EV owners' preferences. That means I want to have a short detour, I want to have a competitive price, I have less waiting time, and this service level agreement is here that I don't want to wait more than this much time waiting for the charging. That's the service level agreement. And we'll be talking about a subscription-based model, but this is built-in criteria. And then of course the vendor's objective, because it has to be a win-win situation for both, and their objective is I want to have more revenues, I want to have better coverage so that many cars can be actually charged within my area, so people will come to my network charging, and also the customer satisfaction, otherwise there will be a lot of charging. If the charging is there in the subscription model, that means the revenues will not be generated by the vendors. So the contribution that we are making are multiple folds. So we are first looking to talk about the subscription-based charging model satisfying certain service level agreement or SLA. That means I want to specify, I don't want to wait more than 45 minutes for charging, no matter where it is. And I'm paying for that. And this service level, subscription level is more like I subscribe to this type of charging thing, almost like a, not a prepaid model, but for example, for the wireless connectivity at home, you can have a premium service, you have a less premium service like that. So you still pay a service subscription, but then my charging rate does not change, whatever I charge, whether my in-network or out-network, that we'll talk about it. Then to do this optimal or approximate EV to charging point assignment, we're taking a matching theoretic approach, and so there are apps that will be developed, and then EVs actually will say, okay, I want to have my charging, and that information goes to a roadside unit for RSU, then RSU actually will be getting requests from different EVs, and then give a preference list out there to different such charging points or charging stations, and that's the way the preference share is to be collected. And in our approach, the novelty comes from both of those, bullet 1 and 2, but the third one is very critical. How do I get the coalition of the preferred charging points? Because multiple EVs actually will be requesting when they are on the road that I want to get charged. Okay? And there is some kind of rank ordering is there. That's why the matching is coming, and the notion of stability also will be coming. Okay? So then we propose two approximation algorithms or heuristics. One is based on what we call preferred coalition dynamic, and that is preferred coalition breeding. And the first one, the PCD, is a little bit more computation intensive, which we have shown experimentally as well as from complexity analysis, but that gives a globally optimal coalition of the preferred charging points that I can go into, and then I have some rank order that I can choose which one to take the service from. But the preferred coalition breeding is more efficient computationally, but that gives a locally optimal heuristic solution. And we do some kind of experiments to, in our method we call it SMEPCA, which is the stable matching theoretic EV charging assignment framework. So the novelty is coming from three different concepts that we mentioned. One is the SLA compliant subscription model. Second thing is that we not only take into the EV owner's perspective, but also the vendor's perspective. And third thing is how do you form very novel way the coalitions. And that's why the algorithm questions come into picture. And as I mentioned, there are two different ways actually one can charge. I just drive and I pay for my service. Right? But the thing is the price can vary because depending on which vendor is providing the service, wherever I go. And also depends on the traffic, my waiting time could be sometimes unlimited. But the method that we are proposing is for subscription-based model. You just pay a service subscription service, and then I specify the SLA, and based on that I do. So for example, these are the specifications that actually are proposed by different, like Tesla network, for example, Toyota network and all, their charging stations. So Tesla has the largest number of charging stations, for example. Okay? So these are the specifications that comes from them, that if you want to do 40 kilowatt hours, that's the first charging, you can do in 10 minutes, for example. And similar 20 kilowatts, 10 kilowatts, right? And we have actually identified from the literature as well as from the vendor specification certain criteria or aspects from the vendor side or from the user side. And we wanted to see that if I do pay-per-recharge model, none of these aspects are actually satisfied. Whereas the subscription model that we are proposing, that actually satisfies all of these criteria. That makes users happy as well as the vendors or the service providers happy. So this is the model that we are using, as I mentioned. The EV owners, they are driving on the road, and they have an app on their for their EV, and then what happens whenever they need to charge their vehicle, they basically send out a message, and that message goes to the RSU, and the RSU collects all the messages that come up, and then creates a preferential list, and do some kind of coalition through this double matching algorithm, and then eventually say, okay, you should go there, because that's what your preferences, like waiting time and all this, so everything's there. Now, for example, Tesla has their in-network service, but they don't have service everywhere. So, if I subscribe to Tesla network in-network service, then I should also get a service from somewhere else, and they have separate agreement. It's almost like a health network that you think. You are in some network, health network, but you can go to some other city, some other country, you can still get the service because they have the agreement. A similar kind of stuff. So, we have notion of in-network and the partner network. And of course, in-network service, let's say if Tesla we are talking about, they get more revenue out of it. If I go to a partner network, that means they have to share some revenue, they make less revenue. And so, based on that, the waiting time, your charging price, and all these things also vary depending on whether you are in-network or partner network. And then in the in-network also, as I get some data, right? The regular charging mechanism, fast charging mechanism. So you can see that's the ordering you can think of. Now, the assumption that we are making in this subscription-based EV charging model, to start with, to keep the simplicity, that all EVs, they have identical battery capacities. Okay? That's a simple assumption that can be actually realized. And then, users in general, they prefer fast charging, not the regular charging, so that they don't have to wait too long. And the third thing is that we always make my information out to the RSU, and the RSU makes the decisions and gives the list, and based on that, I execute. Now, as I mentioned, our objective is to design EV CP. EV is the electrical vehicle, CP is the charging point. A particular charging station may have multiple charging points. Just like you go to a gas station, you have multiple units that you can charge from, right? So EV to CP assignment algorithms that minimize the charging cost to vendors while maintaining the service level agreement for the EV owners. So that's the thing, and we take into account certain criteria, how much charge do I need. For example, sometimes I want to charge ahead of time so that I don't run out of my charge and be in anxiety. Nearby CP, and every charging point also has a capacity, that means how many vehicles they can serve in a particular time frame, and that's what the capacity. As soon as charging limit and maximum waiting time, everything. And one can actually prove that with a simple reduction to knapsack problem, 0 knapsack problem, that this particular problem is NP hard. And this is an optimization version of the problem. I don't want to go into the details of that, but what it says, the 3 different conditions, which will come in the next slide as well. I'm assuming at any particular time an EV can be served only by one charging point. So when I charge from a charging point, no other vehicle can be charged at the same time. Okay? And the second criteria is that each charging point also has a capacity, maximum capacity. And the third thing is that when I'm in the in-network, I'm going for the fast charging, and also I'm complying with my SLA. That means I don't want to wait more than this much of time. And that's part of my agreement when I do the subscription. So in this particular case, of course, I'm talking about this stable matching algorithm, and we have also shown that it is scalable in terms of experimental evaluation, and also it's very effective. Although it's an approximation algorithm, but it actually has a very good proof. That's in terms of the execution time, as well as how much I can charge, what is the waiting time that I have to wait, and all this kind of stuff. Right? But this particular information, the game theory, we call it scheduling game. So it's a stable matching theoretical algorithm, but ultimately I'm actually looking for a game, right? And the game is basically I have a set of EV users, capital S, and capital C is the set of charging points. Then I'm basically talking about a mapping. That means I can have any subset of these charging points that may come from in-network or partner network. Okay? And then of course the three conditions that are mentioned is in the paper. Of course I've given all the formalism, but basically it means that at any time a particular charging point is only serving one EV. Each subcharging point has multiple, has a fixed capacity that the number of CVs it can serve, and of course how I can do the matching. Right? Then in terms of any game theory, that you have the notion of rational behavior, right? So here also you can talk about the similar thing. How do you maintain the rationality? That people will not behave irrationally when actually you are requesting for a charging service. So that's, the rationality is there. And also no pairwise blocking is there because as I mentioned at any time, only a particular charging point can serve only one EV. And based on that, you can actually come to the notion of stable matching. And the stable matching would say that, so basically matching that we get EV-CP pair is stable if and only if it is individually rational and also no pairwise blocking is happening between the two agents. So let's just work out a very simple example first to give the how it works. We are going to machine the formalism to start with. So for example, let's say you have some charging points, the six of them are the charging points, right? And some of them are regular charging points, some of the fast charging point, some of them are in-network, some of them are partner network. Okay, I've just chosen some numbers. And depending on that, users also, as I said, like they don't want to detour too much if they don't get charged in a particular charging point, but they have to go somewhere else. I've given some numbers over here to work out an example that how much detour that the EV SI can tolerate. Okay. So even in network versus out of network, and I have actually codified them with the color, right? So I'm actually doing a simple sorting first. That okay, in network fast charging, in network regular charging, partner network fast charging, partner network regular charging, and based on that I know how much detour I can actually expect. And based on these detour distances, so what was happening? This is an example first, then I'll actually come into the more formalism of these two different heuristics that we talked about. Based on the detour distances, so I can actually find out the preferential list. What is the first charging point that I should target with the minimum detour with my SLA limit as well as the charging capacity that I need to have as well as the pricing. So based on all of these criteria, right? And this is the algorithm, so I'm not expecting everybody to go through that, nor do I want to explain all of the details which is there in the paper. So it is a two-stage matching algorithm. In the first stage, I'm making a proposal. That means every EVs, they make a proposal that I want to do that, and this is my preferential list. Okay? Alright? And so based on that, basically I have a preferential list that comes out. So for example, let's say charging point 4 is requested by multiple EVs. Right? But in a different order, preferential order. And based on that, basically I get a preferential order for charging point 4. And let's say 1, 2, 3, 4, 5, these are the EVs in the IDs and that I get into. So based on that, I can actually get a list of proposals. That's the first phase, a proposal stage. And the second stage is that from there I form a coalition. And based on the coalition, I reject some of the proposals and try to match as best as I can. Okay? So based on that, let's say I have these proposals, 1, 2, 3, 4, 5 that came from the last slide. Then out of that, I see 3 and 5 are the best assignment that I could do, and I can reject the others. That's the reject phase in the algorithm. Okay? And then these stages 1 and 2, I iteratively actually run them until I can actually make the assignments from EV to the CV. So that's actually the coalition formation as well as the assignment. That's the way it's done. Now to do that, so the question will be how do I do this best possible coalition formation? Right? So the two methods that we have given, one is the preferred coalition dynamic, which is based on dynamic programming approach, and the other one is PCG, preferred coalition formation based on the greedy approach. So in the dynamic programming approach, so basically we are talking about the charge requirement. So you have certain parameters that you can see, the charge requirement, effective duration of the waiting time, which is the SLA, and the charging time a particular EV to a particular charging station, and based on that, I can actually first do a simple sorting of the charging requirement, and then from there I go for the assignment. So that was the first step. The second step is, in dynamic programming, you just go through a table lookup or memoization, and from there you have a decisive formulation of the dynamic programming problem, and then you do the assignment. Okay? So we have actually done the algorithm, and of course we have done the analysis, and from there we have also can show that this leads to a globally optimal coalition formation. Okay? And in this particular example, we'll come back to that. What will be the assignment? For that particular example, same example that we have taken, the different EVs and their IDs and corresponding charging time, charging requirement, and the SLA, which is the maximum waiting time for the charging. Based on that, you can actually do the calculation, and you can see that 120 units of charging that you need, and for the 3 and 5, that means 3 is the EV, and the 5 is the charging point, and that's the best assignment. Okay, this is just one example to show. So the other method that we have is greedy method. So instead of just based on the charging requirement and the SLS, we are talking about now charging ratio of the charge requirement and the total wait time that you can expect, which is the SLA. So psi ij divided by delta ij, and based on that we do a sorting, and then we specify certain conditions. In this particular case, the phi is the condition that when do I think that I can have the right kind of assignment. Okay? So if you do that, so again, this particular same example, so both of these methods, PCD and PCG, they basically lead to the same conclusion that this is my assignment. 120 units of charge that you can expect, kilowatt hour, as well as the 3 and 5 is the assignment. This is just an example to show. And for this one, actually, you can do the approximation ratio. We prove that this approximation ratio is not more than 2, but we have strong hints that it is 1.5. And we have some indications, and we'll try to actually prove that. In terms of performance evaluation, so we evaluated both the PCD, preferred coalition dynamic, which is based on dynamic programming, preferred coalition greedy algorithm, and assuming varying the number of electrical vehicles. Of course, this is just a simple set of results that we are showing here, and the charging capacity too, but we actually have some other experiments where we are varying that. And we have taken some specific type of data in the city of Chicago, where basically they have the RSUs implanted over there, a 16 by 16 blocks in the downtown area, and for each city block length is 1/8 mile, and the radius of the roadside units is 1.5 miles, and we have taken some simple numbers for the in-network charging points as well as the out-network partner network charging point, and based on that what you can see that the average charge transferred for the in-network, for the PCG, the greedy algorithm, versus the other algorithm which is dynamic programming based. So the average charge transfer for PCG is lower than the PCD. Okay. So two things are important. One is how much charge you can transfer in a given time, which is the SLA, and the question is how much is the waiting time that you have to tolerate. So here, of course, we now vary the number of EVs and keeping the same capacity of each charging point 2, but later we vary in the next slide the Q as well. So you can see the in-network charge transfer on the left side based on the PCG, PCD, and also we did another random assignment. So if you just do a random assignment of the EVs to CPs, what happens, right? Of course, that performance is not that great. And then on the right side, we show for the same set of data, the SLA analysis, the service level agreement. Here I vary the number of the Q size for each CP, and the total number of EVs we consider is 45. Now these are some numbers we are just showing in the chart over here, but we have done experiments with various varying the EVs as well. You can see that on the right side, what you see is the in-network charge transfer, set from the SLS, and also the EV assignments to the charging points, where the number of the capacity of each charging point varies from 1 through 5 over here. Execution time, we mentioned the PCD, the dynamic programming version, is a little bit more expensive, time of complexity wise, theoretically you can show, of the experimentally as well, compared to the greedy algorithm. So here it shows that. So PCG, PCD, and the random assignment. You can see the green one is the dynamic programming version, and the orange one is the greedy version, and the blue one is the random assignment. And In the bottom, what you see that for the in-network versus out-network, first we able to for different algorithms we run for in-network or the partner network, exactly how the performance changes. So I'm almost there, another slide probably. So what is the conclusion? So we proposed for the first time a service level agreement-based subscription model for EV charging, given that the growth of EVs is much higher, at least 3 times more than the installation of the charging points, which actually creates a lot of anxiety as well as are you going to drive long distance, not even expecting any particular charging station or not, right? And our method is stable matching theory based. The novelty comes from this coalition formation and their analysis. Right? Now we also looked into that, okay, we do this research, that's fine, so what is the impact of that? One is the first 2 bullets that you see are the scientific impact. Okay, then what is the technological impact? So we are actually working on that. This particular method that we proposed is also has a lot of applicability for the public transportation, right? Long haul and last mile deliveries of goods, V2V charging, vehicle to vehicle charging, and also the future potential of future work of co-optimizing the EV charging schedule as well as the trip planning, route planning. So how do you co-optimize that? And we also will be looking into the game theoretic aspect because we have the 2 sets of players are there, EV owners and the service providers or vendors. And they have some orthogonal recovery. I want to maximize revenue as a vendor and users want to pay less, right? That's one part of it. The waiting time is there. They want to increase the throughput, that means number of EVs that they can serve in a particular time. So this is a very nice non-cooperative games situation that we are looking into. In terms of economic impact, of course, we are talking about how to improve the in-network charging mechanism. And also, so far we have considered mostly the static charging cost, but how to incorporate the dynamic charging cost and also when the traffic changes in a stochastic manner. And the social impact-wise, of course, it has a human aspect of it because you're trying to increase the user satisfaction. That's one part of it. Secondly, you are increasing the sustainability because of zero carbon emission and all this kind of stuff. And you are trying to reduce the anxiety. So there's human aspect of it. So one can actually look into whole problem set as a cyber-physical human system. Okay? So this is, so the applicability that we mentioned, so basically this is the view that we have, which is our own diagram, that how we can use our methodology for all the applications that we're talking about, future transportation planning, last mile delivery of goods, and this V2V charging and everything. So that's the we have submitted to a magazine article, so this is the picture that we actually came up with. The codes that we have written, everything is available on the GitHub. So if you want to just take the QR code, all the codes are there for BCG and BCG. So if you want to develop your own algorithm, you should be able to compare with ours as well. And thank you very much.
Yeah, I mean, a quick question. Yes.
Hello. Yeah, thanks for the talk. I have one question that when managing the detour or the duration and finally creating the optimization problem, do you think that we should also include the factors like road condition, the traffic condition, the vehicle type, like what type of vehicle it is? If it's a commercial vehicle, one thing, if it's a personal vehicle, another thing. So do you think this will also have a huge impact on the final optimization problem that
it should? For example, if you see that I said mentioned that the future work deals with dynamic charging costs and dynamic traffic. So stochastic nature of the traffic, it's unpredictable traffic, right? So yeah, it should, right? And when it's commercial versus individual owned or personal vehicle also it matters, right? Because when you talk about the last mile delivery, you're talking about delivery of goods, right? So that will be the more the commercial side. Or you talk about the buses, right? For example, because many countries their buses are EVs. In India also, a lot of their buses are EVs, right? So I think those things are very important. So I would say that we are still at the tip of the iceberg, trying to formulate the problem, and get some algorithms and all, but there's huge scope to work on this particular one. And given that it's a very emerging topic, and we don't have enough charging stations, but some mandates are there, some countries are saying, okay, internal combustion engines will be heading off, right? So the question is, how do you support this infrastructure? Thank you. Very good point, yes.
So, for both the algorithms PCG and PCB, the inputs are basically the state at a particular time instance. So for example, in slide 14, you showed that EVs are EVs have their preferences for charging points, and then the charging points receive the proposals. So as the algorithm proceeds in rounds, you have a rejection round. So when the time changes and new proposals come, it may be that a good proposal now is a bad.
It's a very good point, right? So basically the question is that will my preferential list be stable, right? So by the time I actually get this preferential list and send the information to the EVs, by the time these things change, right? So we have to assume some granularity, right? For example, any game theory solution that you work on in wireless network or other systems that you assume, within a particular time things don't change. But how large is that duration? That I think we have to do a lot of experiments to find out what is the granularity. By the time I make a decision, if things change, of course, I'll be working on a stable information. Right? It will still work, only thing is it will not be the best one at that moment. Yeah. But these are all very good points, and we have to actually address that, but we wanted to just keep the math as well as the algorithms under control at the beginning. But the question will be how do we now make it more and more rigorous and take it to different scenarios.
Okay, all right, nice interactive session. This is, of course, this is the best paper session, and we actually was a little lenient to the time.
Sure.
We are running out of time, so let's thank all the speakers again, and all the best to them for the award.
Thank you.
Yeah, thanks Anisur, and thanks to all the authors. So officially you have a tea break now, but we are almost 4-5, running out of time for the panel. So I request all of you to just grab that tea or coffee and come back. By the time we set up the stage for the panel discussion, we'll have a very interesting panel on systems research and education in India. So please attend that. So hopefully we'll be back within the next 10-15 minutes. And after the panel discussion, we have the town hall meeting. I would request all of you to stay back for the town hall meeting where we are going to discuss what you have liked, what you have not liked for this year ICDCN and your suggestion for the future ICDCN. So please join us for the town hall meeting and the subsequent cultural program and the banquet. Thank you.
How are things? I was actually a long time.
I asked Peter, they said you'll be coming to travel, which I knew. But did you have to leave in Hajar?
Yeah.
I was mentioning the main academic building was there. Everything was under construction. Along with your leadership. Looks very nice.
Can we just talk to center once?
Good. You met Professor Kumar Ghosh before.
We have met before, long time back.
Yeah, I nice.
What do you do? No, not campus. I do multiple things now. So it's like I'm more of a freelancer. Not in government.
What is that? Which one?
yeah, let me get started all over again. So good afternoon and welcome back after a short tea break. We'll have a small discussion on one of the topics that is probably very important for us as educators and as professors. We want to firstly understand the state of systems education in the country and how to sustain, how to grow, and how to kind of build this ecosystem. So to kind of give some perspective and thoughts on this topic, we have picked a diverse panel including Professor Uday Desai, right? So he was the founding director of IIT Hyderabad, the same venue we are all using today. He has a very long list of accomplishments. In the interest of time, I will probably not read out all that, but you know, he's a very well-known educator and like experienced institutional builder, actually, right? So very great to have him on the panel. We also have Professor Sukumar Ghosh, who is a Professor Emeritus at the University of Iowa, where he's been working from a long time. He is also till recently was the steering chair of this conference and also the conference on security, stabilization and safety, known as SSS. He also has a book on distributed computing, right? So that's very timely for this conference and so a well-known educator again. To kind of come from a very young faculty perspective, we have Arnav Paul here today. And Arnav works at BITS Pilani, Goa, and he has this lab called Dash Lab. He has a PhD from Virginia Tech and a postdoc at Oak Ridge National Lab before joining BITS Pilani. He works on a variety of systems topics, including parallel file systems and distributed systems and so on and so forth. So, I mean, it will be good to hear his views as well as an up-and-coming, faculty member at an Indian university. We also have the industry perspective from Rajdeep Dua, and Rajdeep is a Vice President of Engineering at Salesforce. He has more than 2 decades of experience building enterprise software systems with focus on server-side platforms and application stacks. So that's a kind of like a wonderful and diverse set of people that we could hear from today. We'll have about 45 to 50 minutes. So the way we'll probably arrange this is that each of them can tell us their views on essentially 3 to 4 questions that were shared with them a priori. One of the questions is how to summarize or kind of give us a quick summary on the current state of the systems education and research in the country and what is its... No, I'm not projecting here. I'm just using my notes to read out a bit, right? And okay, so, and also how far is this situation sustainable and how do we do, or what do we do to make it more sustainable in terms of manpower, funding, projects, activities, etc. The other question is, what kind of activities should we take up to increase this, pool of people working in the system space, and again, by systems, we are broadly interpreting it as, let us say, any topic that is relevant to the current conference, ICDCN conference, right? Okay. The other question, we want to also address is what is the role of various stakeholders, what should kind of, let us say, the industry do, what would be interested in doing, and what would academia do, what should it take up, etc. And any other points based on their experience and based on their views. So we'll have maybe about 7 to 8 minutes from each of you. And then we'll probably have some questions from the audience. So, in any order is okay, so maybe we could go in the left, right order. So, okay. Yeah, go ahead.
Yeah, good afternoon everyone. So, Rashdeep here, and I would like to thank IIT Hyderabad and ICDCN organizers for inviting me. I think this is a very tricky topic when I came to know that, okay, we are proposing this topic, because there is very little data, at least in the context of India as an ecosystem and especially for computer science education in the systems area, on what is overall policy, right? I think all of you know that there are we have a tier system, right? There are tier 1 colleges which are very well funded like IITs and NITs, and now we have triple ITs. Pretty much focusing on IT and electronics. And then there's a long tail of private colleges which might not be funded that well. Now, and also I think the country overall, especially with the IT revolution, has gone through a phase where it has become much more important to have the right workforce, which is catering to the industry segment, especially I'm coming from the industry. So what I have seen is that some of the top tier colleges, especially the IITs, their curriculum definitely, I'm first talking about the teaching part, is definitely very, very relevant. And I was looking at some of the IIT Bombay courses, especially in distributed computing, they seem like almost on par with what is being taught at Stanford and MIT. And then I started going into more lower tier colleges, and one thing which came out very clearly was that courses became more theoretical. The quality of faculty is definitely a challenge, right, as you go down into, and that is where bulk of our student population is. I'm assuming that this panel discussion is not only for elite colleges, right? And that is the biggest challenge our country faces. 90-95% of our population is going to those lower tier 2 or tier 3 colleges where the quality of faculty might not be that good. And also research funding is very, very limited. And especially if you're talking about systems, networking, this is a networking conference, it reminds me of an episode. There was this guy called Martin Cassetto. I don't know whether you guys know about him or not. So he's considered the father of SDN, software defined networking. So I used to work at VMware, and he was visiting. His company got acquired by VMware, and that became like software defined networking stack of VMware. And I took him around first to IIT Delhi and then IIT Bombay to give some guest lectures. So he was interacting with PhDs. Especially, I was telling him this is like the cream of a country, right? And after talking to them, I think the first reaction he had was, I think all of them are very smart, but why are they working on such outdated topics, right? And this was like 3-4 years ago. It's like not very old story, but it tells you that we have the talent. I think the main challenge is, do we have the right problem statements and infrastructure to support those problem statements? Especially if you look at, so in VMware, virtualization was pretty much invented for x86 architecture at VMware, right? Because the professor at Stanford basically founded the college. And we saw that the curriculum and OS and virtualization actually go hand in hand now. If you look at any OS course in US, actually virtualization is part of it. And I saw in IIT Bombay same thing was happening. But it's a very hard subject to teach. Same is true for networking, especially where networking is going now beyond basic hardware. I think we have the talent, but most of the cream of the talent goes to US and stays there. So how do we get that talent and the right amount of funding for them to be able to first do a research? And most of our colleges are actually teaching colleges, primarily, right, catering to VTechs. Now I think shift is happening. Of course, all of you are much more qualified on the research side than I am, but how do we get that flip where the top tier colleges become more research oriented and they help the lower tier colleges as a teaching colleges? I think IIT Chennai had that NPTEL initiative, right, which I'm sure other IITs are also contributing. But has it really helped? The challenge is it's one way. It's just some videos, but the main challenge is how students at the lower tier colleges get inspired. I think that is where I would like to stop. There is much more I can talk about, and other thing which we can maybe discuss is that how industry can help. Because especially in distributed computing, a lot of innovation is happening in the industry, which is hard for academia to capture, right? So for example, at Salesforce, we wanted to actually start a distributed computing course for our engineers. And we went to IIIT Hyderabad, very close to us, and we have a tie-up. So they were saying that it's very hard for us to teach you guys because you guys already are way ahead of us. Except for some theoretical algorithms and what's happening there. And the infrastructure needed to do experimentation in that area requires a lot of investment. And some of the problems are very proprietary also to the domain, like enterprise for SaaS or PaaS is very different from distributed computing for AI. Right? So I think that is where I'll stop, maybe pass on the baton for others to give their inputs.
Can you hear me? All right. This is a topic that's teacher announced, and you already heard Rajdeep. So I won't go to definition of what you understand by a system. This is a very standard definition from simple Wikipedia. So I'll skip this, and then I'll start from here that systems education or systems research actually builds on background knowledge. This background knowledge is in various areas, like you can start from discrete math, programming skills, networking, some theory, some algorithms. And if this education is not well-rounded, at some point of time, a researcher will suffer. I've heard, my former students, one of the very senior guy in IBM, he says that, I did not study discrete maths properly. And then I'm stuck now with problems. I have to relearn things. I have to find out, what is there, open books and learn things. So this education is important. Now, current state of systems research, once again, this is not based on any quantitative data. This is by gut feeling, and I'm sure that most of us would agree. Rajdeep also pointed out the same thing, that the IITs, so if you think of tiers, IITs, Indians of Science, some triple ITs, some leading universities, they seem to be moving in the right direction. They are doing reasonably good work in systems research. Then the newer IITs, there are 20 plus, I don't know the exact number, and the newer ones, the NITs and more universities, actually, they need to work much harder to succeed in systems research. Not that they are not doing research, but many of them are just working on the low-hanging fruits. And that's not enough. One has to make progress with that. And after that, you think of the private colleges, which is a very unpredictable quality. Very unpredictable quality, no R&D usually. And on top of that, I've heard complaints that from big name employers that many of them are producing unemployable graduates. They have a degree, they have a BTech, they claim that they are as good as any other BTech, but in actual practice they cannot write programs, they cannot do anything. That is a problem. Okay? That's because a large mass of these students, they are actually going to the private colleges. So now let's think of this question: why do we research at all? Do we have to do research? What if we don't do research? So what drives research is institutional mandates or individual passion. In a company, for example, I don't know if any university, the department will ask me, you have to do research on this. Many places that I know of, it is the individual passion. Some faculty members will decide, they have that intellectual freedom. They will just decide that I want to work on this problem, I learned about this problem, I spoke with somebody, that's why I'm working on this problem. Whereas if you go to a company, things might be different. They define, what you have to do. You may like it, you may not like it. So there are both. In some cases there are institutional mandates, and in some cases there are individual passions. Okay? There is another thing which is, in order to succeed in research, it's my experience that you have to get a spark from someplace. You have to get the right kind of mentors. It counts very much. Just as in India, they say that if you have a guru, in most of these things you need a guru. And guru will basically guide you, hold your hand and guide you. Similarly here also, it is important to have right kinds of mentors. Now, the question is, do we have enough role models, leaders, motivators to inspire people in doing systems research? This is a question, because they can inspire their students. Otherwise, it's not anybody's job. And the third question is this, that, who cares about the quality of research? I just, I thought I'd write a paper. I've got 7 days time. I take a problem, I do a simulation, I draw a few curves. I can always find a conference to present that. And they said that I produced a paper. It's almost a write-only paper. No one will read that paper. That's possible. Who cares about that? I don't know. Does the institution actually worry that this guy is not doing proper research? The quality has to go up. If it's a company, then it might be different. But if it's an institution, I don't know. Who cares for this? Now, I was tracking the faculty flow, faculty graduations, who goes where, and it's based on my experience. Once again, I don't have any data for this, so you can start with. The pointer doesn't work. So you start from the IITs, the third box at the top. IITs, Indian Institute of Science, some triple IITs are the top ranked institutions, call them tier 1 if you like. And once they graduate, there was a time when students of IITs, yes?
You can use the mouse pointer if you want.
Oh, okay. Thank you. Okay, so there was a time, maybe 15 years back, 20 years back, or even before that students from IITs, they will go to US or other countries to do PhD. That trend is largely down. These days, students who graduate from the top-ranked IITs, tier 1, most of them go to the private companies. And one reason I was told that is they spend a lot of money. They have to pay about 30 lakhs for the entire program. So naturally, the money has to be covered. They take loan, I don't know. So they do not really care much for, it's a very general statement, they do not care much for, their first destination is probably join a company, good company, and then make some money. We don't blame them. Then, once they go, some of them will come back. Some of them will later on come back. So they go to the private sector. Some might go to other universities. So usually the Ivy League or Stanford, MIT, those places, Berkeley, and some of them will later on come back. A small number of them can come back and join as faculty members. They can join as faculty members here. They can join as faculty members to the newer IITs, triple IITs. That's one possibility. That's one thing that's happening. And so, if you think of research in IITs or the top-ranked institutions, who does research? I don't think very many IIT students, after graduating from here, they will join the IIT as a research scholar. What is happening in most of the cases, as I notice, is that from the NITs, from the universities, and from some private colleges, there are many bright minds there. And many of them, they go to the IITs, and there they contribute to research. And I'm not counting the private colleges. So the point that I'm trying to make is this, that if we really have to improve the state of research, then we need to basically strengthen the mid-tier institutions, because they produce a large number of, many of them cannot get into the top-ranked institution. They get their degrees from here. See, if we can educate them properly, they can probably provide much better support, which leads to much better, quality of research within the country. And some of the challenges here, there are fewer qualified teachers in emerging areas. It's a new hot discipline. Many of the teachers, if teacher is old, who is going to teach them about the new subjects? Because they have to teach to the students in the class. And if you just do a curriculum design or redesign, include all the new topics there, who is going to teach them? So I can copy the curriculum from some top-ranked institution and do that, but that does not help. There may not be enough. There may not be enough teachers. There may not be any teachers sometimes. Particularly, this is the problem very acute in the mid-level or mid-tier colleges. Acute shortage of qualified faculty. And then, okay, so let me just skip this. And so here I'll just conclude by making a few suggestions that in order to, so we have resources within the country, may not be enough. So there in the top tier institutions, there are good teachers, bright minds, more in number. If they could spend some time in the newer IITs, NITs, if there is some program, they come there, they're adequately compensated, spend a year, start a research program, mentor a few students, then they go back to the institution. So that is one thing that I was thinking of. The other one is, regularly organize winter, summer schools. So for example, we are having a conference here. We are getting so many visitors, so many well-known big names. They come here, they stay here for 2, 3 days, 4 days, and then they leave. We could utilize, if they have the time, we could organize these things ahead of time. Then, we could organize, winter school, summer school, by leading research to seek research in emerging areas in our institutions, particularly the mid-tier institutions. And finally, if you want to improve the quality, either use carrots or sticks. Sticks don't work. They're very annoying. So carrots probably is a better thing. So you think of, introducing awards to recognize research achievements and keep the bar reasonably high. It should be achievable, but it should not be impossible. And at the same time, it should not be such that you write 2 papers and then get 1 award, not like that. So recognize research achievements regularly and just keep track of people who are receiving these rewards, follow their progress, try to nurture them, try to support their research as much as possible. So with this, I conclude my talk.
Hi, this is Arnab Paul from BITS Pilani Goa campus. So, I think there were wonderful points made by Rajdeep as well as Professor Ghosh here. So, what I would like to convey is basically based on my experiences. It's been 3 years that I came back from the US and I joined BITS Pilani. Right? It's not an IIT or anything, but it's comparable with the top IITs. The students are also of comparable quality. So I'll just talk about my experiences of how I felt getting into India and systems research and education in India, right? So basically the first important point that I would like to make is students run behind buzzwords, right? So when I talk to students, they are like, I'll do AI/ML, I'll do blockchain, right? So they are just buzzwords. They don't know what is that, right? So that's one of the biggest concerns that I felt to educate them, right? So I'm part of some orientation programs for the first years and all at BITS, and there even the parents of such students, right? First year students, the parents are coming and they are like, my student is doing, my son is doing AI/ML from their 9th standard. So he'll be very good, and can you please recommend him some professor? I'm like, what in AI am I? Right? And this is a first year student, right? So that's one thing that I found lacking among students. Like, no doubt that they are very smart. They have a lot of quality, but I think it's up to us to give them direction, right? And to even motivate them to come to systems research, right? That the backbone of any AI ML algorithm to even succeed at scale, you need systems research for that, right? So the backbone is missing, right? They are just looking at, okay, I need to be a data analyst, it's a high paying money, I'll get placed a lot into a wonderful company. So they are not looking at, okay, for even a data analyst and all, right? You need data lakehouse, you need databases, you need data management, so that you need file system research. Like, there's just too many systems aspects of all of these buzzwords, right? Even blockchain, like fundamentally it's a distributed system, right? So that's one thing that was missing when I started, right? The other thing was the way to teach. So certainly I think the courses need to be not theoretical, and at least the top tier institutes make it a point to not make it theoretical, right? For example, so IT's distributed systems, I've collaborated with NetApp to design that course. NetApp gives access to the softwares of NetApp for the labs to be created, right? But I'm pretty sure these kinds of facilities are not available in second tier institutes, right? So that's something that is missing. And so in BITS Pilani Goa campus, we have an MOU with other Goan universities, the second tier universities. And what we did was, we asked the faculty members of those universities to come and assist the faculty members of BITS Pilani Goa, right? So a lot of people, a lot of faculty members from, say, Goa Engineering College or University of Goa, they came, they spent a semester with us, right? And they were they were doing the course development, they were teaching some lectures, they were teaching the labs. So a lot of such things were happening, and hopefully they would take all of these to back to the institutes, right? So that's another thing that again started like in 2 years, like after I joined the campus. So that's another thing. The third thing that I found was resources, right? So to have quality systems, research and teaching, you need a lot of good resource, okay? For example, when I was taking the Advanced Operating Systems course at Virginia Tech, we used to get access to these data centers and HPC resources and cloud resources, right? So such things are missing. So there's certainly CDAC, and I was talking to CDAC about how we can get access to such resources as educationalists, as academicians from India. But the thing is, those resources are scant, right? Like, there are not a lot of resources for all the institutes in India, right? So that's something that we need to really think about, how to even build such infrastructure for quality systems education. Because in systems, just doing theoretical stuff, I don't think it's sufficient to even attract students or even make them industry ready, right? So there needs to be practical training, right? And that starts from the classroom. So that's something that's extremely important. The fourth thing, that with the evolution of ChatGPT and all, right? So a lot of our grading things should also be evolved, right? So in the distributed systems course that I teach, so for the final exams, I ask them, bring your laptop, bring everything, right? Have ChatGPT, everything, right? But you have to make, like, so your laptop, one of the laptop is Windows, the other laptop is Unix or whatever, right? But make a distributed scheduler in 3 hours, right? And show. and I'll give you some benchmarks to run, and you'll have to show me, right? So be it the Bully algorithm or whatever, right? Like to for fault tolerances and everything, and use ChatGPT, right? Use everything, use Stack Overflow, use ChatGPT, whatever, but build a system, right? So I think these kinds of things are very important, and that's what attracts students as well. That students are also motivated. That hey, like this is something that is very relevant. This is something where I'm building, and like I'm able to see that it's working, right? But so I was talking to where I did my BTech from. So my BTech was from West Bengal University. And I was talking to professors there, and I was asking them have they evolved teaching operating systems, right? But they haven't, right? How I learned, they are still teaching the same thing, right? So that's something that is missing, right? That these lower tier institutes, their faculty needs to be trained, right? So I go for a lot of faculty development programs like the FDPs that are held in India, right? A lot of universities organize these FDP programs. So there, I feel that the sustainability is missing, right? So you give a one-day lecture, there are these faculty members from different institutes that are coming and attending your lecture, and talking about research and talking about teaching, but like, did they learn anything from it? I'm not checking that, right? So that's something that is extremely important to make the FDPs, like the faculty development program, that like I think the model is excellent, but we need to somehow make it sustainable. Like the faculty members who are attending FDP, maybe we are monitoring their progress, stuff like that for the next 1 or 2 semesters, right? So stuff like that, I think there should be something. On the research point of view, I think there are a lot of funding that is given from the government side right now, and there are techniques like the hub and spoke model that is being done right now, right? So that technique should not be done only for research. It should be done for teaching as well, like you suggested, right? So the hub and spoke model works wonderfully well, like for the National Quantum Mission, the supercomputing mission, and all of that. I think that model shouldn't be just for research. There should be the teaching involved as well, because I completely agree that the second tier IITs, the lower, the private colleges, the lower tier private colleges and all, a lot of wonderful students are there, because I was one of those, right? A lot of bright students are there, but they need to, their faculty members need to be trained so that they can be trained in the classroom, right? So that's extremely important. With that, thank you.
At the outset, I'd like to first thank Sajal, thank Arjun and Kishore for inviting me and giving me an opportunity to share my thoughts. Now, so far, the discussion has been more on system research as applied to networking or to computer science. I'll open it up. I'm fundamentally an electrical engineer, but having spent time as a director, I did interact with mechanical engineers, chemical engineers, aerospace engineers, and I learned a lot from them. So I would like to look at it in a slightly broader sense. Whatever they have already said, I agree with them. And I can see, what Arnav was saying, he's trying out a lot of innovative things also at Pilani Goa, and that's very encouraging. And I think many of those things can be tried elsewhere. So fundamentally, what is it that we want to get across? The systems thinking is more important than the specifics of a particular engineering that we're looking at. You want to look at, what we teach by and large is specifics. I would teach the transistor as an example in electronics, or in wireless communication I may talk about modulation systems. Okay, in networking we may talk about a specific protocol which is being used by Wi-Fi systems. But we rarely really get into the complexity of the system from an end to end. And many times after graduation, you do encounter that. So this topic which has been chosen is very important. Also, it's very hard. For one person to really cover that is not that easy. Because today, if you look at complex systems, okay, particularly they will involve various different disciplines coming in. You know, there is a new phrase which has been around, there are centers are there, you know, the cyber-physical systems. Okay. People have been talking about it for nearly 20 years. We have big centers, 25 centers in the country, we deal with it. Now you look at any system which is a cyber-physical system, it will involve components of computer science, components of artificial intelligence, components of electrical engineering, networking, mechanical engineering, physics will come into picture, etc. Okay. Now I think that is something that we need to get across in terms of thinking. The idea is not that they are able to solve systems problem, they are able to kind of put things together, but are they able to think of a system in a broad sense? What I would say, if I look at a complex system, can I break it up into its constituents? Understand the constituents, and can I now reassemble all those constituents and create a better system? Now that is very hard to do. And attempts have been made, I think, across the discipline. Many of the examples were given by my earlier speakers. Okay. So, for example, integrating things also is an equally hard problem in terms of in systems. So let me give some examples. One example I start with, which is a slightly broader example, much more different. And first, I learned from the Japanese. There are many Japanese in the audience out here, and Sajal was saying that next year ICDCN will be in Japan. We talk about a maker lab, we talk about building systems. The Japanese have a course on braking systems, and they talk about breaker lab. At least my colleagues at University of Tokyo used to discuss that. So there was one professor called Hori-san. I think some of the IT faculty would remember him. He used to come here and offer some programs on innovation. So he was saying what they do is they go to a place called Akihabara, which is it's like a place where you can buy a lot of electronic goods. Anybody who has been to Tokyo will know Akihabara. They buy different things. They buy a washing machine, they buy a refrigerator, a television, etc. Then they'll have a group of 2 or 3 students, and their whole job is to take it apart. So you look at a washing machine as an example. You can pick the latest washing machine with fuzzy logic or whatnot, you want to talk about it. Their whole job is to take the whole system apart and see different components. So if you look at even something simple as a washing machine, which all of us have at our home, there is a bit of software component, there is electronics in it, there is mechanical engineering in it, there is to some extent, I can be totally wrong here, my colleagues in chemical can correct me, some amount of chemical because I am putting detergent in it. And the detergent has to react with the materials which are out there, not just the cloth, but the drum has to remain in good shape with that detergent, etc. Now here is not a very complex system in my mind, but the students learn how to take it apart, they look at constituents, and they learn the function of each constituent. In fact, what I was told by Hori-san, they don't ask them to put it together. He said, once you have taken it apart good enough, just understand the constituents and what each constituent. I think that was a great learning lesson. And I wish institutions, I've been talking about it at many institutes, and I wish they would do that with first year students. Let them do it, and particularly more so in India, because very few of our students have the luxury of breaking things at home. In fact, if you buy something, it is so expensive, the parents barely let you touch it. Okay? If they let you touch it, they'll say you touch it carefully. Just do this, don't do that. Normally, because of the various cost structures and income structures in India, you don't want the thing to break down. Trust me, if you take something apart, it is a lot harder to put it together. I've rebuilt carburetors, and suddenly you find a few screws remaining and you wonder, where in heavens will this go? This was the days of carburetors. They no longer exist. In IIT Hyderabad, at one time we had a nice course, and in fact I would say it was a great experiment which didn't work, because you need terrific faculty. So the first year we used to have a course where you take 2 or 3 such very complex systems. I recall 2 systems we had. One was an aircraft. Now if you look at aircraft, it's a very complex system with complex safety measures. It will involve networking if you want. It will involve computer science, a lot of software programming is there. Flight dynamics, flight control, material science, ergonomics, you name it. Every aspect of engineering that you can think of, okay, is present in an aircraft. And the idea was to teach this complex system and how different engineering disciplines come together to create something which at least a certain section of the population in India uses it on a regular basis. Some other section uses it once in a while, and maybe some third section may never use it. But still, it is something that we see all over the place today. Okay? And I think the difficulty was to find a faculty who could teach that. If you find an aerospace engineer, the guy will be very good at flight dynamics. Okay? You find a control theory, flight control. You find a material science person, they talk about composites, everything, but they won't know the other stuff. Now, how do you find a faculty who can teach this complex system called the aircraft? Okay. And you can look at it, to me, networking systems is a much more simpler system. It is not as complex as an aircraft. The other example we took, and there networking plays a big role, is the cell phone. So the idea was to pick systems which are very complex, but also which are used almost in day-to-day life. Of course, cell phones are far more prevalent than aircrafts. Practically everybody carries one on their body. Even the relatively not so well-to-do in India have a 3,000 rupee, 5,000 rupee smartphone. Now, talk about the whole thing. Starting with the display, what is happening with the screen. You hear about this, whatever, the toughened glass or whatever is there on top. What is it? Gorilla glass or something they call it, right? Now, what is this gorilla glass? In fact, I ask students, we talk about LCD display. How many of you have broken a cell phone and seen what is LCD? What is the liquid crystal doing out there? Is really liquid out there? Are there crystals popping out? What is happening out there? No, none of us do that. You don't let our students also break the phone and see it. Okay. Now that was the objective, to teach the whole thing, not just from a computer science perspective. Networking obviously comes in because your phone has to connect to a network. There are protocols operating out there both for Wi-Fi, for GSM, etc., etc. Again, very difficult to find one faculty who could do all of it. A faculty could do wireless communication and talk about cell phones. In fact, I'm sure there are many in the audience out there who can do that. But then that is not what cell phone is, right? Today it's a big communicator. There's hardly any programming. Of course, there are many who do programming. In fact, I know of some of the faculty and students. Okay. But so how do you teach that? And similarly, one can narrate other examples also. So my point is that if you want to really get into systems education, not systems education for computer science or for networking, that is one small component, and certainly it has to be done, it's important. But really to get systems thinking. The other course that we had to quickly mention, I don't remember the course on drones. Now drone also is a reasonably complex system. It's not an aircraft, but it has elements of the aircraft built into it. In some sense, we can use that as an example to see how an aircraft might work. Now that's a complex system. One can design it, one can build it, one can fly it in coordination, like what you see on TV, etc., etc. So one has to think creatively of examples of complex systems which can be taught and which can be fun for the students. A complex system teaching should not become a drudgery for the student. That's where the problem comes. The day it becomes drudgery, the students will get turned off and they're not going to be excited about it. And it's not easy. I would say that course that we taught, I think we did it for 2 or 3 years and then we stopped it. Maybe it's sort of like MPP and Arjun and others can remember it better than I do. Okay. But somehow we could not just get a team of faculty to cover that particular course. But I would still love to have it. Because I think that is where you can really get across this so-called systems thinking. I'm not even talking about system technology, anything like that. Number one. We had another course, I don't remember details about it, Surya taught it, called Art of Engineering. Again, that I would say was more of a systems level thing. Now, having said that, one thing I like to get across, and this is a very high level thing and a broad thing, is our approach should not be prescriptive. So I do not want to prescribe saying that you must teach a system thinking, level thinking. Let the faculty decide. We can discuss it, debate it. Finally, the faculty should have the freedom, okay, to do what they want. Like what Arnab talked about, the kind of evaluation system that he had in this course, that hey, you do whatever you want, bring everything under the sun. I need a distributed scheduler, and I will give you a template program or problem on which it has to work. I think that is much better than having a conventional exam where you question 1, question 2, question 3. I think it's a great idea. Things like that, but that will come only when the faculty has the freedom to do it. Now, going back to the earlier discussion, in an IIT, you have that freedom. You go from IIT to NIT, triple IT, the freedom goes down. You go to a private institute, in India particularly. Private has a very different meaning in Japan or in US. Okay. In fact, US, Japan, some of the private institutions are top-notch. KO is the best, one of the top-notch university in Japan. Stanford is one of the best universities, it's private. India is the other way around. Okay. Now, you go to a private university, the freedom is just not there. There are too many regulatory constraints. Actually, it's not that. Students are good, as Arnab said. In fact, now I interact a lot more. And I would say I interact with at least about 10, 15 private universities across the country, not just in Hyderabad area. I go further south, further north. Okay. And the freedom is much less. The do's and do nots have been very much prescribed by AICDE and by UGC. And they are stuck. Many times I make suggestions coming from an IIT kind of a background. And they say, no sir, we have to get this approval, we have to get that approval, we can't do this, we can't do that. I'll give a simple example, I don't even take names. I interact with the institute in Hyderabad called Vigyan Jyoti, a long name, BNRV, Vigyan Jyoti Institute of Technology, etc. They want to have a PhD program. Now they're not asking for money, by the way, nothing. They said, we will pay the PhD, and they agreed with me, we'll pay as much as what IITs are paying or NITs are paying or IITs, the government scale. Okay. But they cannot take a PhD student unless that fellow has been approved by JNTU. So JNTU gave them, in 1 year, 2 PhD students. I'm not joking, I'm deliberately saying it. I would tell my colleagues, what is this? How can somebody, and they're not asking JNTU for money. They are saying, if students want to come to us, let us all take them. No, they cannot take more than the number that has been prescribed and vetted by JNTU. Now, with such constraints, what kind of R&D can go on, what innovative courses can occur? So I think, one of the things is we have to minimize, if you really want to get innovation into your education, like, systems teaching will be an innovation. There are few courses in the standard curriculum we talk about system thinking, and you have to innovate and create some new courses. For that, you need the freedom. So yes, IITs should do that. I think they should do a lot more of it. And my message is that don't worry about systems course in electrical engineering or systems course in wireless communication or systems in networking. Look at a systems course in engineering, which will involve all disciplines in engineering, going from computer science, electrical, mechanical, biomedical, material science, metallurgy, chemical engineering, and that is where the real complex systems come in. So I stop at this point. I'll be happy to answer.
So I guess we'll have time for maybe 3 or 4 questions. Probably I'll ask the first question and then I'll leave it open to everyone. So I think one of the things that Rajdeep and Arnav mentioned is about how do we teach the early undergraduate courses, maybe limiting to even computer science or other kind of disciplines in the interest of the conference teams. So for example, I agree completely with Arnav where, the way we teach operating systems across the country is a little, I'm not saying, I'm not using the same brush for the entire country, but in a large majority, I think the textbook is pretty old, probably older than me, and right. So I think that is where some of the example lectures or example systems or some material that maybe the few who do it very well should be able to curate and promote and do that kind of upbringing in some sense. Right? Alright, and I think one aspect really that your industry would be very, let's say, very interested in pitching in, because this is the pool that you hire from eventually, right? So I'll open it to questions, because I think that we are a little short of time, so anyone with any questions to the panelists, please. Yeah, there is one question.
So hi. So Arnab, you mentioned that the availability of infrastructure for systems research and training, and I think what you mentioned was availability and then training. So maybe just the availability is not a problem, but you need the right software as well as the right trainers for it. So one thing that Coursera and other platforms, NPTEL, have done is they have democratized availability of high quality courses for all the tier 2 and tier 3 institutes, and they can use them. Do you think something like that would be feasible for some open access infrastructure for systems research and training as well?
Yeah, I think that's an excellent point, right? So I know that in US there's something called, say, Cloud Lab, right, which is funded by the NSF. And a lot of institutes in the US who don't have infrastructure like that, they use Cloud Lab, right? So something like that, if that could be made available in India, right? Something like Cloud Lab, if that could be made available in India, that would be really nice. And then you could make, so in BITS at least, in our department what we are trying to do is a private cloud kind of, right? There is an HPC, but we also are investing on a private cloud because as you know, AWS, Azure, these are very, very expensive, right? So hardly very few people can actually afford it. Even for teaching purposes, right? Like AWS, Azure, they give some credits, but not a lot, right? So that's something that we need to build as a country, I guess. Like a lot of Param computers are there in a lot of IITs right now. So if a lot of if a portion of those Param computers can be given for just open access, right? But right now there are lots of rules and regulations to even access those. Right? So things like that I think will make lives easier for a lot of institutes who don't have access to those infrastructure.
I think just adding to what he's saying, so what has happened is now there are software stacks available which can actually almost simulate a real environment, right? I think in networking space there are a bunch of tools, I remember in SDN, which do that. It will allow you to simulate the whole topology of your network. So then there are open source projects like OpenStack, I'm not sure if you've heard of them. So OpenStack, you can run actually on a single laptop, and you can also run on complete data center. For example, Reliance Jio platform runs on OpenStack. The underlying concepts remain the same, even the software remains the same. The Python stack on which the scheduling and the storage, networking, compute, orchestration happens, it's the same. It's just that the underlying infra layer, are you connecting a single disk or you're connecting a whole data storage layer, right? Are you connecting a KVM or you're connecting a VMware stack behind the scenes? So that can vary, but it will actually at least get you started, right? And then I remember some of the companies like you talked about NetApp, VMware does the same thing. And I think it's harder with companies like Amazon or Google because they will never expose their infrastructure directly to you. They will only expose it through a browser. So actually the fun is not how you interact with their stack through the browser, but the underlying concepts, which you can get through the open source software. So, but I know if you really want to go to the scale of, but then you need funding.
I'll make one kind of announcement here. I have not tried it out. So a few days ago, about around December 21st, I think, I had a fireside chat with Bhavesh Agarwal. I think many of you would have heard of Bhavesh Agarwal, Electric. So he has developed this Krutrim cloud, AI cloud. So in the fireside chat, I asked him, can you allow people to use it, the students and faculty? Excuse me. So it was not for everyone. So he said for all IIT students and IIT faculty, you can log in and use it. Now this was a statement he made at the INE National Convention. Okay, I was present, so if you want, you can write down the address, email ID to check with him. Ask a student, please do that because if not, I'll pester them. So the email address is abhishek.chauhan1. If you want, you can note it down, at olaelectric.com. So this was an open declaration at the INA National Convention. INA is Indian National Academy of Engineering. The only thing is he put I asked him, can all students and faculty do it? He said, well, let's wait. So I said, okay, think about it. So if you're an IIT faculty or an IIT student, check it out with Abhishek and see what he says. You can give my name. You can even mention the INA convention, no problem with that. And say that Bhavesh made. I put this on my Facebook page. That's why I'm referring to this. And I don't know how many of them read it. So I just want a few people to try it out. Otherwise, I will pester Bhavesh saying that, hey, you promised what's going on.
I have a question for Professor Desai. So you talked about the AICT issues and the restrictions and so on. So what is the mechanism for course correction for all these AICT and UGC rules for various institutes? And what is the general turnaround time for such things to such reforms?
Course correction meaning what?
So for example, right now there is this restrictions, right, that JNTU imposes on the college. So if you want to kind of liberalize that a little bit, what is the turnaround time and what is the mechanism?
It's a very hard thing to do, first of all. In fact, I must say at least the current AICT's chairman is open to conversation. I do talk to him. In fact, as an example, I feel 160 credits are too many. And at one time he agreed. Remember, we went through in IIT Hyderabad and brought it down to somewhere between 25 to 35, 125 to 135, based on what is happening in many top leading American universities. He too agreed in the beginning. He said, I think he's a graduate of Purdue. He said, I would like to bring it down to the Purdue level. I said, great, let's just do that. He said, I'll try to do it. A few months later, he said, look, you are saying this, but there are many others who want to increase it. So it's a very complex thing because of the large country that is there and one central body. There are a lot of conflicting and push-pull things are there. But I said, can we bring it down to some extent? So what you were saying, there are many courses which are offered which are like soft courses. He said that's why you can manage it. So you can say only so much. So at least I thought he was quite open to it. He did look at it, he thought about it. And he could do only so much, he could not. He said, if I do it, I'll also get a backlash from many places. I myself have faced it. I am on many boards of private universities. Some agree with me. But many say, no, we have to teach this, we have to teach that. There is no limit to what they say. Everybody feels that, look, if what I know is not taught, then the curriculum is not complete. Then the student is dead, unfortunately. So, on a broader level, your question is a very important question, but a very hard thing to do. It is not so easy to change rules and regulations. In fact, unfortunately, what happens in India is you keep adding rules and regulations. I've rarely seen somebody say, okay, when this new rule is added, the old rule is out. It never happens. It just becomes one more layer. And it's a very, I've tried very hard. Wherever I go, I say, do this, do that. If the people are nice, they're polite, they'll say, yes, we'll try to do it, etc. People are not polite, they will say, you don't know. This is all wrong. IIT is different. Don't talk about IIT. You have no idea what goes on in India. Then I give example. It actually happened to me. I'm not third party story. I said, look, I interact with Anurag University, Vigyan Jyoti, etc. He said, no, those are top tier private universities. You don't know what is happening in the rest of the country. Now, how much should I know? Maybe I should go to Kacharoli and take that example. Then they will listen to me. So, what you are saying is a Herculean task. Try to do it.
Hello, I am Saurabh. I have one thing is, government have one initiative called Virtual Lab by IIT Bombay and many of the institute contributing to develop the lab. So it's there already. IIT Hyderabad, IIT Hyderabad and NIT Surat. Many people are contributing to develop the lab so that second tier and third tier institutes can have that. But I think those things are not aware of those people. My question to Professor Ghosh, you have mentioned that people are writing papers and publishing in some conferences and something who are reading that one. But I think universities are putting the constant that you have to publish this many of numbers instead of quantities. So how do you ensure the quantities versus the qualities? for those. I'm not talking about top institute, I'm not talking about the second or third tier institute.
I completely agree that writing papers or forcing people to write papers for the sake of promotion is the wrong approach. It does not help anybody. Because if you think you have to write a paper, you can always write a paper. And if you think that you have to publish that in a conference, you can always find a conference for that. But that is not the right approach. I don't know why this rule was introduced. Probably, I don't know, it's just my guess that there are not enough teachers, so even before PhD, if people want to start teaching, then they can be accepted as assistant professors. But then for promotion to associate level, they have to show something. That probably is the reason. I may be wrong, I don't know that. But that is certainly something that is a useless exercise. People who really think of research as a long-term goal, they will keep on doing this. For them, this does not help in most of the cases. Because after they have gotten their PhD, write 3 papers and publish them, they have written the last paper. They will not write another paper. So what's your question? Your question is about how to change this?
Yeah, means how do you ensure that? Because while recruitment a new faculty, recruiting a new faculty, those universities may be looking how many journals or conferences they will have rather than where they publish.
Yes, that's the wrong approach. That's the wrong approach. And unfortunately, this is true in the US also, because they say that when someone becomes up for tenure, in many cases, the deans don't really care much about or don't understand much about the quality of the papers, but they simply count. They simply count. This problem is always there. So one thing is this, that peer review is probably the best possible thing. If you really write a paper and you submit it to a respectable conference, and you know what conference is a respectable conference, you look at the acceptance ratio. If you can get your paper accepted in those kind of conferences, maybe 1 paper is good enough, as opposed to 3 papers or 5 papers. But who will finally, the decision makers, whether they can be convinced, is something that I don't know. That's a problem. And I don't have a solution for that.
So perhaps the last question is here. Okay. So one of the ideas that was suggested in the slides was rewarding top-tier faculty members to spend some time in a college at a lower hierarchy. How about the other way around? Rewarding faculty members at these lower level, lower hierarchy places to be promoted or to get a faculty position at this higher hierarchy rank institution. So the more concretely, I mean that if someone has joined NIT or then they should have some promotions or a clear pathway to get to a high ranked institute. Do we have such things, or is it a good idea to have such things?
I don't know whether there is anything like this here, because I'm not aware of that. Anybody knows anything about it?
So as you mentioned, people from NIT Goa, University of Goa, spending time with your department, and then trying to see how they do in the next 2 years, 3 years. I think that is like a sustainable model. But there is one usual trouble or one usual hurdle in general that I noticed. The place that is sending out these people also often worry about, what would they, or how, for example, for them it is a lost resource, right? So if that money to manpower issues resolved, somehow things get a little more easier actually.
True. So that's why I think this model will only work if it's like Goa is a small state. It's a small state, right? So it works in Goa, and BITS has MOUs with all of these other institutes in Goa, and they are not spending the entire semester, like they are not in BITS Goa, right? So they just come for those 1 or 2 hours of that day when the course is being taught, spend 1 hour of teaching and then 1 hour of just planning the course, right? And then they are going back, teaching their own course, whatever they are doing, right, in their institute. So it's a win-win situation, kind of. Like, there is no loss of any resources from that institute. So in Goa, at least it's working, right? So similarly, maybe Hyderabad also does this, right? IIT Hyderabad, IIT Hyderabad, like they team up and have the other institutes, and that can spread hopefully all over India. That's one model, and I have seen, like, I have interacted with a lot of faculty members, and they have gone back and they have implemented those, and students are very happy. Because one of the things that I've seen is, I was talking to other faculty members, there's a loss of PhD applicants, right, in India, and I think worldwide. People in computer science, students in computer science are not really looking at PhD as an option because there are other lucrative, like money is there elsewhere, right? So so what we do as BITS is we go to these local institutes, other institutes, and we talk about our research, right? And there, like, these faculty members are also our advocate, right? That, okay, there are these good faculty members in BITS who are doing good research, so they will be sending their students, right? So it's like a win-win for everyone, kind of. So that's a model that is working right now, touchwood, but yeah.
Yeah. So one model we tried in the past in one of the organization was, so the professors came on as I would say faculty intern for 6 months. So basically they took off from the institute, it was from IIT Delhi. And they spent like 6 months with us. And because they wanted the industry experience. So that model I've seen it work. But we've actually funded that. It was like more like giving back to the education ecosystem. But I think the industry could take that initiative, that would be quite useful.
Yes, since Arnav mentioned about number of PhD students going down, I just tell you about one of the initiatives that we took at the University of Iowa, and we also had difficulty in getting good students. So what we did was this, that we found out that there are many remote colleges where there are bright students, but they don't have, and they may be, their families in farming, but they don't have any idea about what research is. They have their own notion, they have to pay a lot of money to get into research. But we tell them that, well, you will get some kind of support, fellowship for a couple of years, or maybe teaching assistantship. Then they're convinced, initially hesitant. But so what we did was this, periodically, our faculty members will go, pick some of these colleges, go give a talk, maybe not one talk, maybe 2, 3 talks. Enough students get interested there, and finally some of them will apply, and we have found excellent students from them.
Just to add to everything, I think these things are tried, but the scale is not very large. So it's more of an individual, the two institutions interacting. Many a times, faculty firms say whatever, tier 2, tier 3 may come to an IIT and spend some time. But it is more, not even institute side, none of the two institutes are involved. Say summertime, 3 months. There is not much teaching at the parent institute where the faculty is there. You are at IIT Bombay, they will come and spend time in your lab. Okay. So that is one part. That, institute to institute to some extent, formalization is not there. Informal arrangements are there and people do that. But there is another, in Indian context, there is a bit of a problem. Mobility is not easy. If a young faculty who's married, say, has a kid maybe grandparents paying, etc. Suddenly the fellow has to go from a college in Hyderabad to say IIT Delhi. IIT Delhi is willing to take. It's not easy because the whole family structure gets disturbed at that point. You know, lot of things have to be taken care. The fellow cannot fly back and forth that easily. So many a time, though you want to go, because of certain social structures which also are much better today in terms of mobility than they were 20 years ago or 25 years ago, no doubt about it. But still they are not as conducive to mobility. Because the person cannot just take his whole family and go there. Even a professor at IIT Delhi is willing to take, say, somebody from a local college, even for a year. First thing the professor will say, I cannot guarantee you accommodation. Now, where are you going to live in Delhi? You'll be bankrupt, right? I mean, whatever honorarium they may pay, money they pay, you can't manage it. And this is the story. Some of the newer institutes like Hyderabad, IIT Hyderabad may be a little better, but here also campus accommodation is already a difficult task, I think. Okay. But you go to, I know for IIT Bombay for sure, even regular faculty members who are hired, for the first year they don't get campus accommodation. Okay. These are full-fledged faculty members at IIT Bombay. So there are a lot of other social structures which come into picture, or the social constraints that come in to create the kind of mobility. But I think we need to work towards it. It is a very important thing, and I can cite examples of what we tried here. It will take too much time. I won't get into it. But we need to work at it. And try multiple models. There is no one answer to it. Whatever model you can have, experiment with it and see how it works.
So I think with that thoughts, we'll close the panel discussion. I think we'll have a lot of work to do going forward, and so I'm sure Sanjeev, me, and Satya will certainly follow up on that, and let's see some of the things can be done in the near future. Thanks everyone for attending, and let's have a
Come close. Sir, look here, sir. Sir, look here. Esteem. Thank you, sir. Sir, this side.
అక్కడ దిగా బోర్డు మీద అది కూడా అదొకటేగా
Sir, one picture. Take a comment which may not be, just take it in the right spirit. These mementos, particularly after retirement, I have no space. As a director, I had a big office, I could keep it. And my wife, when I go there, one more free week, leave it outside. I'm not joking. So I have a suggestion. It's a good idea to give. There is, I think, a group called, I think, Praveen Bhagwat. I don't know how many of you have heard of him. In Pune, he has started an NGO. I think it's called 14trees.com or something. So what we did, I don't know whether they have done it this year. There is a competitive conference where I am going. It's like ComsNets. Many of you might have been gone to ComsNets also. So instead of giving a memento, what we do is we pay Praveen Bhagwat at 14.com or 14trees.com. They plant a tree in your name. And what they have done, I have not experimented with this, they give you a QR code and you can see your tree being taken care. So year by year, month by year, you can see the tree with your name at the bottom growing. I don't know how much they charge. Maybe they charge 2,000 rupees, 53,000. I don't know the exact amount. But I thought that is a better memento given the current environmental situation in the world.
Excuse me, sir. Look here. Sir. Sir, look here. Hold out.
Okay.
Sir. Thank you. Sir, this sir. Okay. Sir, okay. Thank you.
డిన్నర్ ఎందుకు ఎన్ని తీసుకుంటారు డిన్నర్ తీసినావు డిన్నర్ ఆల్రెడీ డిన్నర్ ఎన్ని
డిన్నర్ ఏం తీరాలన్నా
మరి ఎందుకున్నారు
డిన్నర్
యాక్టింగ్ చేయమంటే
తీయాలి
మరి ఇంకేందో డిన్నర్ ఏం చేద్దాం ఇక్కడ ఉండి డిన్నర్ చేయాలా ఇప్పుడు డాన్స్ చేస్తారా ఎవరన్నా అర్థం అయిపోతారు కదా
నేను మనకి స్టూడెంట్స్
ఇప్పుడు స్టూడెంట్స్ వస్తారు
స్టేట్ మెంబర్స్
This year it has come to that. So we need to coordinate. I think we need to coordinate and make sure we don't overlap.
See, our meeting is the second week, this is the first week, then it was very well. Sometimes we share.
No, but sometimes what happens is international footy, Indian night is okay. We do it next week also, won't matter much. But the international participants.
That's the way it used to be.
That's then we do have people interested in Europe and Japan.
Yeah, you should start.
Chalo.
Thank you so much.
I'll see you in Bangalore.
I cannot make it now.
అంటే వెళ్ళిపో మీటింగ్ అంతా వెళ్ళిపోనా మీటింగ్ చేయాలా మనం యాక్టింగ్
That's why they are coming to them. But, yeah, so I have Sure, yeah. Sunday, why don't you share the link to page so that he can connect his laptop? He does not have a laptop. No, he doesn't. So when he presents about Japan, he needs to connect his laptop, so he needs the link. Can you keep two laptops there? Just give me a link here. Or do you have it in the memories? Exactly, that may be the best thing.
Yeah, so using a pen drive to put it in the same link.
What is happening now? What can you share? Just high shot a slope chamber? মেসেজটা ছিল 6 o'clock 6 o'clock তো অফিসিয়াল অ্যানাউন্সমেন্ট অফ কি অফিসিয়াল স্টাডি প্রসাদ কেদিয়াম ওখানে আছে ও কল করেছিল শুরু হলো 6টা ইনস্টিটিউট অ্যানাউন্স করেছিল 6টায় প্রোগ্রাম শুরু হওয়ার কথা কোথায় থাকবে স্পিক ব্যাকে বক্তৃতা the professionalism to not in that সবাই তো আমাদের ভাবতে হবে দুটো পাঁচের শুরু হয়েছে এটা মিটিং হয়েছে বসে অনলাইনে পরিয়ামের মাইকটা তো আছে আবার কলার মাইকটা দরকার নেই ওগুলো তো প্রচুর এক্সট্রা টাইম ওগুলোতে ওদের যে ওখানে ডিসকানেক্ট হয়ে গেল না ডিসকানেক্ট হয়নি তারপর ল্যাপটপে আছে ওদের বোধ হয় ভয়েসটা রিডাইরেক্ট করা যাচ্ছিল না ওরা শুনতে পাচ্ছে না ওরা শুনতে পাচ্ছে আমরা শুনতে পাচ্ছি কালকে ওইখানে ঘরটাতে সাউন্ড ছিল বলে কোনো অসুবিধা হয় না ওতে সাউন্ড ছিল মেশিনটা থেকে কোথায় ওই ভয়েসটা ওদেরকে রিডাইরেক্ট করতে হবে আমি কীভাবে চালাচ্ছি আর বুঝতে পারছি আমি কোনো চেয়ার নিতে প্যানেল
basically about few announcements about ICDCN 2026 and a total time session. And also few notes from the program chairs for online. I don't know if I'm audible to you. So, Kiara, I'm audible? Okay, great. And Peter is also there, so I think you can ask Kiara and Peter to, yeah. So Kiara, maybe you can just say a few words if you have anything to say. And let me just to tell you, Kiara, as you all know, is the general chair.
He's saying something.
Program chair of the networking session.
Increase the volume. She's saying something. We can't hear.
Yeah, one second. I can hear you, the audience is not able to hear you. Just give me 1 minute.
There should be sound feed, right? No. I think the sound feed it should be open up. Kiara, can you hear us?
Yeah. Kiara, can you hear us?
Yes, I can hear you.
All of us can hear you as well. Thank you.
Okay, perfect. So hello everyone. I'm Chiara Boldrini. I served as the PC chair for the networking track. So it was an honor to serve in this role. I hope you have enjoyed the program so far. So it's really a pity for me not to be there with you, but I hope everything went well. And from what I heard, it was an amazing conference. So I'm really sorry that I had to miss out on this. So I will just say hello and give you a few statistics about the networking track. Then I will leave the floor to Peter for the distributed computing track. So we received 28 submissions, and of these we accepted 12 papers. These submissions received reviews from our 28 PC members, which I have to thank. Really, they were excellent in the feedback they provided, and they provided also timely reviews, which is, not to be taken for granted since we are all overburdened with reviews. So, just a few words from me to say thanks to everyone, to those who take the papers, those reviewed papers, and to all the attendees for making the conference such a great event. Peter, do you want to say a few words?
Sure, yeah. I will also. Hi, everyone. So I was serving the distributed computing track as PC chair. So I will also give you some statistics for the distributed computing track. So this year we had.
Peter, if you have a video, you can turn on. We're not able to see you yet.
Oh, okay. Let me see what's going on here with my webcam. Yeah, somehow I'm not able to get video. Okay. Let me just share this one slide that I have. Can you see my screen?
Yes. Yes.
Okay. Yeah, so for the distributed computing track, we had 28 PC members, and we also used 27 external sub-reviewers where it made sense. And we had 49 submissions in total this year, which is a slight increase to 2024, where there were only 37. And yeah, each submission was, of course, assigned to 3 PC members. And in the end, we ended up accepting 13 full papers and 7 short papers. So some of these short papers were full paper submissions that were then invited to be short papers. And I'm actually happy to say that all of these short paper invitations were accepted by the authors. So it's short papers, having short papers seems to have been a popular option. Yeah, so that's it from my side. And I would like to again thank all the PC members and also the external sub-reviewers for their hard work on this program.
If I may add, I'm sure Peter will concur. We want to thank also Sandeep and Satya and Amos for doing such a great job. They were super supportive, and we really appreciated that. And also the publication chairs, the web chair, so the publicity chairs, everybody did an amazing job, and so I think this is the time to thank everyone.
You can ask them to stay on for the presentation of Japan.
So thanks, Peter and Kiera. Thanks for the wonderful effort that you all have put in. We'll thank everybody else. We also thank you. Okay, thanks for your efforts. So with that, we'll continue. I'll just also continue. I also want to take this occasion to thank the local organizing team, which was here. I have to share my screen. Yeah. So I'm continuing where Sandeep left yesterday. Okay, I have to I think I should need to share my present. I'm presenting. This is the same set of slides, which continue. So, after thanking all the sponsors, which is where Sandeep's talk, now let me reiterate the people who were there, but they're not here today. So the team that was there behind us for the local organizing were all these. So starting with MVP Rao, many of you know him, big applause for him. So he was right next to me. Anything I would go and ask him. So, and next to me, was BMR, 2 officers next to me. I'd go trouble them all the time, and they were always there for me. Okay. And of course, and Praveen Tamanna, he was the one who's responsible for getting Marvel. Like, Marvel was already started. Marvel was here, and they gave good amount of support, and Praveen continuously interacted with them. Thanks to that. Yeah. And Saurabh, you might have seen it. So what happened is December, many people left. I was only there, and I was having difficulty. And Saurabh he went on vacation early and came back, and he was helping their room, seeing the rooms, banquet, all the things he was there. He took us around, very helpful. And Kotaro was also there. And Kotaro took care of all the registration tasks right from the morning. He used to registration started at 8, he used to be there by 8 or 8:30 and took care of the registration very meticulously. Thanks to all of that. And Zishen, Das, he's my colleague who helped us with finding all the food menu, food options. And he would have an excellent banquet this evening, and he was helpful in setting up all of that. I'm rushing through all this because of lack of time. Okay, but yeah. But the help that they've done is really great. And of course, Rameshwar Pratap, he was here yesterday. He helped up with the setting up the auditorium and he's choosing what to do, which auditorium to choose. He was there. Okay, and he was helping the mementos, the registration kit. Ashish Mishra was there. And Rajesh Kedia was there and giving support. Okay, thanks to all of them. Anthony Franklin was the head of the department. He generally supported us with funds. Okay, and a lot of financial and emotional support. And our director, B.S. Murthy, big thank for setting up the institute, setting up the process for supporting all the law conferences. And the CSE staff. So Vijay Chakravarti, you would have seen, he was there. He came with purchasing mementos. He went around, did a lot of stuff, buying. And also the webmaster. Yesterday, he was also webmaster. He did multiple things, not just one. He was there for web things. And Surya Prakash is a go-to man for anything. He was there for anything we could go talk to him. And Shivakumar was taking care of all the web design, the certificates, all the design. So we could see the design anywhere on the big screens. Shiva did that. And Praveen Kumar took care of all the banners, everything. He completely took care of the design of the banners. Okay, this is there. And Sunita's name is forever, there will be ICDCN afterwards. She designed the ICDCN logo, which ICDCN committee decided to adopt. It's a very people like it. Okay. Of course, she took help of others, but she was there. Well, unfortunately, none of them are here, but they really helped that. And our CC, Center for Continuing Education, the entire auditorium, everything is maintained by them. They're completely in the background. But anything, they were there for everything. We had to basically, the registration, everything was taken care of them. So all the registration money accounts to be taken care by the CC, these staff, Priyanka, Maharashtra, they were there for some time around, and Mr. Sridhar. These are the people. Yeah, and of course the student volunteers. You can't thank them. Unfortunately, there are too many people that I can't thank them individually. I just put one photo for them.
That's good. That's good.
That's good. With that, I'll stop. Thanks, children. And big thanks to IIT Hyderabad. Yes, even I should also thank IIT Hyderabad. And all of you, just below this pillar, there's I love IIT Hyderabad. Please take your photos here. And of course, there's also a media wall here. You can take it here, take a photo here, and also at that place. And put in your LinkedIn that you took photos, came to ICDCN and took your photos here. Okay, at the media wall. Especially, we spend a lot of money for the media wall. At least for that, take pictures. Okay, with that, I'll stop. And I think I request for ICDCN 2026 for Japanese team here, they will present.
Where is that laptop? So
you can access it?
No, here's a memory stick.
Yes,
pen drive. I think after this, just ask for a feedback. I think there's no time. We have to walk there, right? Everybody's gone. No, so nobody's there.
Yasumoto from Nice, Japan. And so maybe some of you might already know. We are hosting next ICDCN 2026 in Nara, Japan. So the date is from January 5th to 8th. Okay, and so as you may know, Nara is a very historical place with many famous temples, and also there are wild deers, so you can read that. And so our conference venue is located in the center of Nara Park, and so this is called Iraka, and in the next page I will try to, this is video, but it might not work. No? Yeah, so I'll skip. So maybe you can find this video on the web page of conference venue called Kasugano International Forum Iraq. Okay? Yeah, and so okay, yeah. And some of you may already know the location of Nara, but I will explain. And Nara is located in the center of Japan, and so it's near to Kyoto and Osaka. And you can come to Nara through Tokyo International Airport, and then fly to Osaka, and then take a bus. Or you may take Shinkansen train to Kyoto, and then change train. And so it takes about 2 hours and a half from Tokyo to Kyoto, and takes 40 minutes from Kyoto to Nara. And also from Osaka, there's a direct bus. So I think it's convenient. Okay, and so as I said, Nara is a very famous historical place, and so this is a World Heritage Site. And Nara was the capital of Japan in Heian period, so that is the 8th century, so 1300 years ago. And so as you may know, the famous temple shrine like Todaiji, Big Buddha, and Kofukuji Temple and Kasuga Shrine. Yeah, and so this is the venue, Nara Kasugano International Forum. As I said, so it is located in the Nara Park. And in the Nara Park, there are a lot of deers, and so you can interact with deers. And so it's a 20 minutes walk from nearest station. Yeah, and also there are many hotels available near the station. And so this venue is especially famous for no. No is a traditional Japanese play. And so there is a special no theater. Yeah, so in general, so the no is played here, but we can use this no theater for the main track, and every main track presenter can make presentation in this stage. And so we also have a very beautiful lobby for coffee break. Yeah. Okay, and so currently the organizing committee is not yet decided completely, but so I'm one of the general co-chairs, and another one will be decided very soon. And general vice chair is Hirozumi Yamaguchi from Osaka University, Japan, and so the TPC co-chair is Simone Silvestri from University of Kentucky, USA, and another TPC co-chair is decided very soon. And some other chairs are listed here. Yeah. And so we really look forward to welcoming you in Japan next year. And so please prepare your papers and submit papers. Please organize workshops, and so we look forward many attending. Yeah. So see you next year. Thank you very much.
I think sure because I think people are ready to go, right? You can maybe thank you and Peter. Yeah, you can. You can ask. No, no. I think you have to go there, right? Very good. So you can mention that anybody has any feedback, they can give it to you or us, right? So
Yeah, of course.
time is short.
Yeah, so Peter Kiera will quickly take the feedback from the audience. So I know the time is short and many of you have left. Anybody has any way to improve the system, any comments? Feel free. This is a town hall, but almost every town hall meeting. And many of you may be waiting to go hear the Saroj Master, Amjad Ali Khan playing.
Drop us an email.
Right. Yeah. So 2 minutes we'll give to see any feedback, otherwise you can send an email. Any pressing, burning issues you felt? Louder, please. Please don't say registration fees. Okay. Okay. Because that is not in our hands. I mean, yeah. Since you already know these things, I think it's under discussion. I assume that, but that's the part I'm actually going to talk about. So I mean, you see, like mostly like Indian authors, so we feel like yeah, it's not in our hands. We are helpless there. Okay. So the solution to that is ICDCN should form a society and generate funds and give it to every institution. That is the only way. Maybe you are working on that, so that's fine. Yeah. Professor Sajadas can add any other things are fantastic. Yes.
It is in the works. It got delayed, but yeah, we talked about it. Hopefully,
it's in the process. Hopefully, we are going to.
Okay. Hopefully, in future editions, it will be lower.
And anybody wants to host in the future, they can always drop us a mail.
Yeah. And anybody is interested to hosting, I don't know if you heard Professor Sajadas. Anybody who wants to host ICDCN, not necessarily in India, even abroad, anywhere, right? I'm sure you're open. You can come forward. Is there an email to whom?
To any of us, to you, to Sandeep, to me.
Okay.
Usually we discuss the town hall meeting, but because of the concert, so we don't want anybody to be delayed and miss that opportunity, right? Usually you spend half an hour time to talk about anybody willing to host, also hear experiences, what work, what did not work, but I think that Amjad Ali Khan is attracting our attention right now. But you're more than welcome to send us email. My email is very simple, s@mst.edu. We send to Sandeep, to Shakti, and they can pass it on us.
Maybe you want to tell me end at 6:15, 6:10, no? Shall we end at 6:15, 5 more minutes?
Maybe you can
We can stop.
I think we have to walk there, right? It's a golden opportunity for all of us. How many ICDCN can host Amjad Ali Khan? We are taking the opportunity to say that it's part of the
Bye, Kiera. We're going for the cultural event. Bye, Peter and Kiera. Thanks.
Okay. Bye bye. Have fun.
Yeah, sure.
Bye bye.
Bye. Ciao. We'll see you there.
Yes, pervasive and mobile computing. So, it is, I think PMC is for the networking track, and for distributed computing, they have some theoretical computer science. John is handling that. So, yeah, so basically they will look into the papers and send invitations to send.
गेस्ट हाउस যাচ্ছে ये তারপর 6:30 गेस्ट हाউসে যে চেঞ্জ করে ওটা 6:30 তে শুরু হবে আমরা गेस्ट হাউসে যাচ্ছি হ্যাঁ যাবো যে চেঞ্জ চল যাবে তো না ভালো লাগছে